Everyone, Hugo Bowne-Anderson here. Welcome to a very special live stream and interactive workshop. I'm so excited to be here with Ravin Kumar. What is up, Ravin?
Not much. Excited to get in, and I'm seeing all these messages coming on Discord. So if you haven't joined Discord and posted yet, go ahead. But that's
Please
currently what
do.
I'm
And actually, while I'm introing, would you mind putting the Discord link, Ravin, in the YouTube chat as well?
on. Yes, let me get that.
So we can have it there. And we've got people joining from Spain, 4 a.m. Thank you so much for joining. You're already a hero. And please do introduce yourself. Let us know a particular type of food you like. I'm here with like the modern version of a poke bowl. Essentially, it's a late lunch here. I'm in Sydney, Australia, and it's Monday, and I can tell you the future is bright and beautiful. Ravin, you're in the Bay Area, right?
I'm
You're
very 7 p.m. So I'm here on a Sunday night with you folks. It was the best window we could find to get you and I in a room, which is what it worked
exactly.
out
This
to
was
be.
actually the only time that we could figure out that Ravin and I could put 3 hours aside together. Now, Ravin is going to share the Discord link in the chat, as I just said. If you enjoy this, please do share it with friends and like and subscribe to the channel as well. We have lots of podcasts and we're doing increasing amounts of workshops and those types of things. Now, Ravin, would you mind actually, all of this will be in the Discord, but if you could put the GitHub link in the YouTube chat as well, that would be much appreciated. And could you let me know, can you see our GitHub repository?
Is it a
On the
question for me, Hugo, or for the question for the
Yep,
audience?
to you.
I can see a GitHub repository. It should be public. I just made it public about 30 minutes ago.
Fantastic. So we have this GitHub repository. Please, everyone, do jump in. So I'm going to tell you a bit about this workshop. Um, Pardon me, I'm getting over a little bug as well. Well, that's not going to stop any of us today. And please do continue to introduce yourself in the chat. It'll be great to know what your interest in such things are. Do you work in AI, machine learning, data scientist? You're an analyst trying to break in. Are you an executive or a marketer trying to understand a bit more about the space? But all that having been said, we're here today for a workshop called Building AI for Real World Use Cases from Basics to Production. And the idea is to take you from understanding the fundamentals of AI-powered systems to building, evaluating, and optimizing them for real-world use. Okay, so it was inspired by a talk that Ravin gave in a workshop that a course I teach called LLM-powered applications for data scientists and software engineers. And I'm going to put this in the chat as well. Shameless self-promotion. But if you like this workshop and you're interested, please do join the course sometime or share with friends or anything along those lines. And in the Discord, you can chat with a lot of people who took the first cohort. We had over 80 people from all types of wonderful places, from Meta and Netflix and Ford and Adobe and lots of wonderful people. So in the talk Ravin gave in the workshop, he shared a lot of his work at Google. He was at Google then. He's still at Google, but he's actually now at DeepMind. So congratulations on the move as well, Ravin. But he shared his work on Notebook, LM, and Mariner. And that inspired a workshop we wanted to teach as part of that course, but we decided to do it publicly so as many people as possible can get involved. So what this is, it's a practical, hands-on approach to building LLM-powered classification systems that run locally. Workflow focus, we're diving into prompting, evaluation, optimization, not just model selection, but we will cover that, and a chance to iteratively build and refine an AI system using Gemma 2B. Gemma 2B or not to be, I must apologize for such a horrible joke, plus Olama, while just learning how real-world AI applications are developed. But because the term productionization means so much and different things to different people, I just want to say this is what this isn't. It is not a deep dive into every LLM tool or framework. We focus on workflow, not exhaustive tool coverage. It's not a step-by-step AI recipe book. What we're going to do is experiment, iterate, and debug instead of following rigid instructions, because that's what we do. It's not a guide to large-scale production deployment. We're not doing load balancing. It's about learning the fundamentals, but also scaling beyond local models. I'm sorry, scaling beyond local models is a separate challenge. So I'll just talk you through a few of the things that we'll cover. And thanks so much, Brad, who's in the chat right now, saying epic course, referring to Stefan and my Maven course that Ravin spoke at. 5 stars, really appreciate it. So one of the things that I think is missed, we focus a lot on the generative capabilities of all these large language models, or that small large language models is the joke, right? We're really talking about language models, but we don't talk about how they can be used for classic machine learning challenges, such as zero-shot classification, which we'll be doing today, and in-context learning. So what we'll be doing is starting by using Gemma 2B and Olama locally to predict whether a sports team is from the US or Australia. What we'll see immediately is we're not just working with a model, we're building a system. We're integrating models, data, a front end, a database, and the core model we'll use is Gemma 2B running locally via Olama. And really excited for Ravin to take us into that. Then we'll start thinking about evaluation, because remember, we're building products that ideally move beyond demos and they serve some purpose. So we need to figure out how well they work. The first way we do that is vibe-based, just getting a sense of things. Then we will build what's called an evaluation harness. And essentially that's a fancy term for repeatable evaluation. So let's say you switch out a model, you can then rerun your harness and see what's up, see whether it broke your system or made it better or whatever. And we'll be doing that in notebooks and then using a script as well. And once we have that solid evaluation process, we optimize and refine the system. So we'll try different models, we'll measure accuracy, speed. One thing is we don't really have to measure cost, do we, Ravin? Because we're running these models ourselves. We're not pinging APIs that can get smashed, right?
I mean, right now we don't have to worry about cost. So we'll get to the end and say when you're going to deploy this app, everyone's going to have to worry about cost. But
Exactly.
for prototyping, we're not going to be running any API credits.
Um, for those who checked out the instructions beforehand, we're not going to go and do all the setup. For those who did it beforehand, fantastic. If you didn't, please do just watch along otherwise, or try to do some of these as we introduce by installing Olama, pulling the required models, setting up the Python environment. But if you find yourself falling behind, then just watch and you can do it later. That's the vibe I take here. So I think with all that having been said, Ravin, do you want to take the stage, and you're going to give some slides and then we're going to jump into building some AI systems, right?
That sounds good.
And I just need to give you screen share. Yep, you got it.
Perfect.
The boss.
Awesome. We got that. So like Hugo said, if you didn't get things set up beforehand, you've got a good maybe 5 to 10 minutes to get it going. But if not, let's just go through slides and we'll continue on from there. So let me talk through what are we going to be doing today. By now, I'm sure all of you have seen some super fantastic AI apps. You've probably interacted with one, or you've seen them. You've seen a demo at a tech blog, or sorry, at a tech event or dev event. You've probably heard about them at least. And I do have to say that a lot of the AI apps you see right now are sort of like Michelin-starred meals. They're very well presented. They're very well thought through. Hundreds, often at least tens, but often hundreds of people who are experts have like finally crafted this beautiful presentation using a world-class kitchen to get you this. There's a lot of things going on behind the scenes to make it happen. And I think this is a lot of us aspire to be able to do something to this level. And I imagine that's why a lot of you may be in this class right now to learn, as at least Hugo and I promised, to learn what's going on with AI apps. Now, to set expectations, though, we are not going to be creating these Michelin-starred, readily available apps in this class. What we're going to be doing is creating actually the two starter meals, I think, for either the Australians or the Americans. I was actually just talking to my friend this morning, and she was saying, "Isn't it weird that Americans eat peanut butter and jelly is like their childhood meal?" And at least spending some time down south a little bit. I know Vegemite, right? Hugo is something that is a
Absolutely. A cheese and Vegemite sandwich was a staple for me. And then also Vegemite and potato chips, like crisps, not hot chips. Like put some, we have Smith's crisps or something like that. It's one of the great meals.
I got to try that next time I come down. So the reason I bring this up is that you could argue that the Michelin-starred meal and these are the same thing You could argue they're very different, right? And that one is very high level and finely crafted, and this is more like a basic thing. But we also have to remember that they're both food, and Michelin starred chefs had to start somewhere. They didn't start in their childhood immediately making these fantastic meals. And so that's what we're Hugo and I are going to start with you today. We're really just going to put together the basics, the basic Vegemite and crust sandwich or a peanut butter jelly sandwich if you're American, or whatever the equivalent basic food is for you. But we're going to be doing that in an AI app form. So it's going to feel, maybe not as polished or not as tasty or not as refined as you might have had with an AI app experience, but all the fundamentals are exactly the same. We're going to be going through the major steps that it takes to make these AI apps, whether you're making these basic sandwiches or you're making these Michelin starred meals. Hugo, I think I wanted to turn it over to you for the next slide, right?
Absolutely. And very much appreciate that. I'm just going to see if I can. No, we're good. So I just want to say something we're kind of taking you through here. Well, we've talked about the process will go from building an AI system to doing some sort of evaluation to then iterating and optimizing. And in the course that Stefan and I teach, which this was inspired by, the way we frame kind of the new emergent software development lifecycle for generative AI is first you build something, right? And that's what we'll be doing. Then you deploy it. And we'll actually show you how to deploy a basic app. Once again, it's not going to be a production app, but it's something that you can send friends and play around with yourself as opposed to just writing scripts or using the command line or using a notebook. And then you want to monitor and get insight into what is actually happening. So you want to be able to look at your results and have observability, look at the traces, look at the conversations, identify failure modes, evaluate them. Evaluate them at an individual level. What are their LLMs doing? Let's say you have a pipeline it reads PDFs, then does some sort of information retrieval, then does some generative component on top of that. You may have several LLM calls within there. You want to be able to give them thumbs up and thumbs down and reasons, but then tie them to broader business metrics. So you want to think about evaluation there. And then you want to use that to build again. You want to have this rapid iteration. Maybe you're doing this hourly or daily as you start rolling it out to your first users, or using synthetic data generation to build your data flywheel for your app. But as you iterate, maybe you're doing more prompt engineering, you're using different embeddings, applying business logic, fine tuning. When you're deploying, you might be using unit tests and continuous integration and versioning. All of these types of things. So we'll be touching on the basics of a lot of this, but I just want you to this is very different to the kind of classic paradigm of like build, test, deploy, right? And then a lot of software then iterates. You get V1, then 1.1, then 1.2, and those types of things. But usually in traditional software development, you know how your app is going to, you know what you need to test for and how it's going to perform and how people are going to use it. Whereas, I mean, the first rule of any type of conversational software is if you think you know what your users are going to say, you definitely don't, right? So if you wouldn't mind going to the next slide, Ravin. Once again, just to give you a sense of the overall structure, we're going to jump into the first notebook, build our MVP AI system with models, data, front-end, database. We'll be doing zero-shot learning for text classification, classify footy teams, football teams as US or Australian using Gemma 2B. Then we'll be doing some vibes. We're going to try prompts, get a vibe, try another prompt. Try them with different teams and get a feel for what our performance is. Then we'll be doing repeatable evaluations. So we'll build an eval harness, which we'll use programmatically for a bunch of teams. And then we'll see how it performs with different type of data, news articles. And then we'll think through optimization and productionization. So try different models, measure accuracy, speed, cost, track each metric in production, and think about running experiments to improve it and improve one of these and check for effects on others. So with all that having been said, perhaps you'd like to take the reins now, Ravin, and jump into the first notebook.
Sure. So I think I saw there's a couple questions about grabbing the GitHub, and it looks like Hugo has posted a note. So if anybody still has challenges, just post again and let us know. But let's just jump into the first notebook. This one is more of an explanation that I'll go through before handing it back to Hugo. Just like Hugo said, what we're going to do is we're going to build an MVP AI system. So rather than just prompting or using just command line tools entirely, we're going to start with what the UI looks like and how it works through a fantastic Grad.io app that Hugo built. What's nice is that Hugo has also built in a SQLite data store into set, which allows for observability. And these are all the components we need to observe what's going on with our system. Now, the model we're going to be using is Gemma 2. We're going to talk at the end why I picked Gemma 2 in more precise detail and what it would take to try other different models. But just to start, I picked Gemma 2 for two reasons. One is that I know how it works really well. It's a model that I built, or helped build with a great team. So frankly, it was easier for me to write this tutorial for you folks. The other big reason, though, is when Hugo and I were talking about ways to do this tutorial, we made a strong choice at the beginning to keep everything local. That makes it easier for you, so you don't have to worry about API keys or rate limits or anything like that. It's also going to show you how you can iterate with models on your own computer. And Gemma 2B is a fairly strong model that runs on a lot of people's laptops, things like that. You don't need to have a huge, big desktop or a data center to run a Gemma 2B sized model. So you're going to see us really dive into the Gemma 2B model, but we will, and I should specifically say the Gemma 2 2B model, and we will get back to other LLMs in step 4.
And maybe I'll just add one thing to that, Ravin. Funnily, when we were preparing this workshop, I accidentally was using Gemma 2B, not Gemma 2 2B, and I just wasn't getting the performance you were getting. And I was pulling I was going to say my proverbial hair out. I was pulling my beard out. But what's interesting is also that these local models, which, as you say, we can run locally on relatively straightforward hardware, right? Like, I can run on my like modern MacBook Pro, I can run far more than 2B models, right? So it doesn't actually take a huge amount of compute these days. But the reason I'm stating this is Gemma, the difference between Gemma 2B and Gemma 2 2B is huge. And they were only like 6 months apart or something like that, right?
Yeah, I think the team put in a lot of work to release a strong model in Gemma 1 and then really follow up on that in Gemma 2. So, I mean, again, I'm biased because I worked on it, but I think it's a very cool model. But it also underlies another point, actually 2 points that you pointed out, Hugo. One is that we can definitely build apps or even starts of apps with smaller models. You don't always have to start with the bigger model. So that's something we're going to get back to later in this course as we talk about repeatable evaluations. And also in that theme is that a lot of you folks know, I mean, Hugo and I definitely know, this field keeps changing every 2, 3, 4 months, right? Like new things keep coming out, new models keep coming out. So you're going to hear this theme from us that keeps coming up with repeatable evals, repeatable test harnesses, observing um, because in this changing landscape, you want to be able to test the next thing without having to redo all of your vibe evals. But I'm getting a little ahead of myself. We'll get to that in a
And
little
just
bit.
quickly, Ravin, we do have one question which I think is really important. And do feel free to ask questions in YouTube chat or Discord. Mr. Me77 says, what is the easiest way without being a lawyer to understand what you can and cannot do with Gemma? E.g., like terms of service. Like, can I use it? Can I use it for anything or?
I guess if you're asking for the lawyer answer and me not being a lawyer, I would have read the terms of service and maybe abide by whatever the model vendor has. I don't have the Gemma terms of service off the top of my head, but maybe more speaking on the user side, I tend to use Gemma 2 for whatever I need to use it for, because it's running on my local computer and you're able to prompt it with what you like. So. My general advice: read the terms of service. Try and be respectful. I mean, as people put models out there, we want them to be a force for good in the world. But they are local models that you can fine tune. You can deploy into apps. You can host yourself. Like you just have a lot of flexibility with your portability of these local models.
Awesome. So tell us about Olama now.
So Olama is a project that I'm not we neither Higa and I are affiliated with in particular, but I think you and I both really use Olama as a tool. So Olama um is a really nicely packaged runner for a variety of open models. These folks I think early on in the open weights ecosystem built a nice Go wrapper on top of what was then the Llama series of models, but then they kept expanding to all models, actually not to all, to many open models, including Gemma, which is why we're using it here. But they also built a really nice featured set on top of it. As we're going to be seeing in this course, they make it really easy to they make it really easy to pull down models, as I hope you've already done, not just Gemma too, but a variety of models. They make it really easy to test them out, as we're going to be doing in Notebook 2. But then they make it really easy to call these from Python and a bunch of different clients, a REST client and others. So it's a really quick way to do ML ops for single node models, which is why we are using it here for this tutorial. Now, I will say, if you, as a quick aside, maybe I'm again skipping ahead a little bit. When you start moving to production grade, like multiple servers or super big models, then Olama starts becoming not necessarily a tool for you. But if you want to just get started and get going, Olama is a great tool to have on your local desktop. So some of the notes that Hugo wrote, which I should also point out, yeah, they're pre-configured for multiple models, which is very nice. The Olama is very good about detecting the accelerators on your computer, so you don't have to mess around with PyTorch or CUDA drivers and figure all that out, which is very challenging, I have to say, having done it myself. So it's really great at just figuring all that stuff out for you. And because of all the interfaces it has, it makes it very quick to iterate, as we're going to see again here in just a moment. So what
Ravin,
we
we
have
have a
here.
great question from
Oh, yeah.
Siddharth Malhotra. How is using Olama different from Hugging Face? When would you use Olama and when would you use Hugging Face?
So I think the one big thing is, and people are gonna have to. I apologize if I get anything wrong because different tools are changing so fast. But I'm pretty sure that there is not a training interface in Olama. Olama is an inference only
Mm,
tool set, and it's very good at inference. But if you want to start doing fine tuning or model architectures or diving deeper into the internals of the model, then something like VLM or Hugging Face is better. I saw the question about VLM as well. I think Vila LLM has more knobs for very fast inference, but it's more fiddly. So it's kind of like a manual car. You get more controls, but you got to be able to handle them. And Hugging Face has the training, so it means that you can take your car and bolt on new parts or take off parts or tune them. I will say one connection between the two, which is something I've done, is you can use Hugging Face LoRa to train a fine-tuned model in what's called parameter efficient tuning. We're getting a little bit outside of the realm of the tutorial, but you folks are here, so you're gonna get some bonus. So you can do some training in what's called parameter efficient tuning through a LoRa adapter. Then you can package that LoRa adapter, and then you can import it into Olama, so you have your customized model ready to go for you at any point. So they are complementary tools in the local open models toolbox.
totally. Thank you, Ravin. Let's jump in.
All right,
Do you
Hugo.
want to just close your close the file system and just maximize your screen a bit?
I was gonna
So,
say I'll just hand it over straight to you, and then you got full control.
oh, wait, I thought you were going to take us through the first code, and then I was going to take us through the app.
Oh, yes, I'm sorry. I'm jumping ahead of myself. Let me go through the first code, and yes, I will give it back to Hugo for the app. So let's just um Hugo, you mentioned I should minimize something.
Yeah, just close the file system and then just zoom in slightly on the code.
Ah, okay, yeah, make it easier
Yeah,
for you to read.
that's great.
Okay. So what we're seeing here is one of the OLAM interfaces, which we're going to be using pretty soon here. We're going to be using the Python client for Olama. So here we have the imports where we're grabbing the Olama chat object and the chat response object. Um, what we have here is we're calling a model, which in this case is Gemma 2 2B. We're going to be calling different strings later, which we'll talk about in Notebook 4. But I have a small Python function here that takes the model, it takes the messages, or it takes, in this case, one message, which is the prompt. It'll run that, get a response, and then we're going to pull out the content. So if I say hello to the class from late night PST, and I run it, you should see here that we get a model, they get a response that is bespoke to this prompt. Let's make class awesome, even if it's past bedtime in some parts of the world. I could say a late night from late night Australia, early morning, or actually mid-afternoon.
Exactly. It's 2:30. It's nearly my nap time. So maybe we're doing notebook 3. Oh, no, I'm kidding.
So let me run this one, and okay, we get a different response. They are getting into the sunshine. We definitely know they are in Australia. So what I would suggest is try running this cell. We're going to be running a lot of Python cells pretty soon here. So if you haven't tried already, you're going to want to make sure this is working as I hand it off to Hugo to cover the app.
Thank you so much, Ravin. So we're going to now jump in, and can you let me know, can you see my screen, Ravin, on Zoom?
I can see your screen. It's looking good.
Great. I just wanted to say, Ravin and I are on Zoom doing this on YouTube, and we're chatting on Discord as well. This is the first time not only we're teaching this workshop, but we're experimenting with this format. So any feedback, super encouraged, and would be very useful. But you can see I'm jumping into the notebook here, and I'm going to build the app in a second. But I just want to talk you through what's happening first. Okay. So we're going to use Gradio, which is actually part of the Hugging Face ecosystem, okay? So it's one of the easiest ways to spin up interactive front ends for AI applications. Like I can like have a model running and I can just shoot it to Ravin immediately. I can do it locally, then I can expose a public URL to share with him, which I can set to be, I can, require authentication easily, or set a password, or set a timeout, or that type of stuff. And we'll see how bloody easy it actually is. Pardon my French or Australian English, but it's when I get excited. What you'll actually see is here in this iFace, I'm creating a Gradio interface to that accesses the chat with model function. I get inputs, a text box, and type your message here, have an output, a title, description, then I launch it. That's like 6 lines of code or something, right? In order to get, a little app that I can share with people. So what we're actually doing is here we're importing Gradio and Olama, defining the model, and you can see I need to change that to Gemma 2 to be, right? Then we create a function to chat with the model, and that's exactly the same as what Ravin has done up there. Then we're building the interface, and then we launch the app. So what I'm going to do is now jump into, I'm not doing this, I'm using VS Code for this, but what you'll see, let me get this right, is that I'm in this, in the same file structure as you, and I have this apps directory, and I have an app Gradio file there. And you see I'm using Gemma 2, and this is exactly the code that I showed you above. And you'll see I'm able to do this with 18 lines of code. And in fact, with, the empty space lines, it's more like 13 or 14 lines of code. So without further ado, I've got a new keyboard that I'm not quite accustomed to. It's the first time I've ever had a mechanical keyboard, Ravin. So I've become that type of dude. But it's fun. It's just loud, which is why I wanted to. So Python apps, I'm just going to run this and see what's up. Okay, that's running on a local URL. Look how easy they make it for me to be able to share something public as well. So I'm going to take this and paste it here. And look, we've got this chat with Gemma. And actually, well, what I was going to say, I was going to change it to Gemma 2, but I don't really care at the moment. Enter a message and get a response. So, hey, what's up? We're doing a live stream tutorial teaching people to build LLMs
And
don't find typos, so I'm chill with that.
before you hit submit, zoom in a little bit, Hugo, so the folks can see.
Yeah, of course. Thanks, mate. Great. And look, Gradio cleverly reorients itself. Hey, what's up? We're doing a live stream tutorial teaching people to build AI systems using you, Gemma 2. That is, we even have people joining from Spain where it's 4 a.m. Okay. So now I'm going to submit this. The demo gods. Wow. Wow, that's awesome. It sounds like an epic session with a global audience. I'm ready to rock and roll, even though my creators might be rolling their eyes a bit right now. I think Gemma just wants to know if she can start singing in karaoke for them. Let me wild. Let me know what kind of AI systems we're building. Is it voice recognition, creative writing, or something more adventurous? I'm stoked for this. Incredible. Now, I'm actually gonna do something saying it's zero shot classification. Now, the reason I'm doing this is to demonstrate something that if you haven't played around with these types of things so much, you may think that there'd be memory here. Okay. But the truth is, let's see. It's thinking, okay, right. So fascinating. Let's dive into zero shot classification. Now, that could be, it's interesting that it went hard, and that's why it took so long. Well, it didn't take that long. It took longer than I thought it would. But it's important to note that even when building basic systems like this, there is no memory. And right. And if you've used ChatGPT and Claude, and this is the first time doing something like this, APIs don't have memory. Local models don't have memory. And what you need to do is actually build out some sort of memory yourself. The most naive way to do it, which we do in the course, among other things, is to prepend all the conversation to the prompt we're giving here. But there are far cleverer ways to actually deal with memory. But that's just a little aside. Ravin, I'm going to move on to logging now. I'm wondering, is there anything you would add here?
No, I think I want to highlight what Hugo said there is this is, in my opinion, a really great demo of a basic app. And you can see how a front end connects to Olama on the back end. But I think Hugo gave you a taste as well that modern apps have a lot more complexity behind them and how they handle things. So again, want to reinforce that we're going to be showing you the basics here, but then giving you pointers like Hugo's course, for instance, but other references for where you can dive next to start getting the app experience that you want to build. Um, but I don't want to delay too much from what Hugo said, which is something that I think a lot of people forget about these apps is the logs and the data are super important. So Hugo, I do think it's high time for you to show about
Yeah,
logging work.
exa exactly. And I'm just going to share my screen again. I am going to, if someone could share this in the chat, it's just difficult to demo while doing this. I do encourage everyone to check out building effective agents by Anthropic. And in fact, I'll put a link later. We're doing a lightning lesson on Maven, which is free, about implementing these types of agentic patterns. But what Anthropic did last December was helped us, something we're all thinking about, helped us reframe what we think of as agents and more thinking about LLMs with tools, right? The reason this is relevant now is we've got inputs and outputs, but we want to be able to read and write to memory as well, which is the first thing. Then we want to think about retrieval. Then we want to think about tools. And to Ravin's point, maybe you don't want to, ship, a production app using Gradio. Maybe you want to build, your own front end or something like that. But in order to build these MVPs, it's eminently useful. And similarly, we're about to jump in and use SQLite to log all our interactions with our app now. And maybe you don't want to do that when you go to product. Maybe you do. SQLite is one of the most amazing technologies in the world, as far as I'm concerned, one of the most useful and impactful. But maybe you want to use Postgres at some point, or something, or whatever it is, or cloud-based services, right? So why are we even doing this? Why tracing? So tracing is collecting traces. All that means is the conversations and data around them, essentially. So building an AI system isn't just about getting a response. It's about understanding and improving how your model behaves over time. Okay. So observability helps us track inputs, outputs, model decisions, which makes debugging and seeing our failure modes and iteration easier. If you have like an agentic system, that let's take the example of reading a PDF. If you look at your traces, maybe you see the biggest failure mode is actually in the optical character recognition, in the OCR, in the PDF. And if you fix that, maybe you get 20% lift, as opposed to, doing some hot new infinite RAG or whatever it is, right? Tracing conversations lets us spot patterns, catch failure cases, and fine-tune our system for better performance. Also allows us to make more data-driven decisions. And as we'll see, looking at your data in a spreadsheet and maybe doing a pivot table or something like that could be eminently more useful than a multi-agentic architecture. And I'll also link to a live stream I did as part of the course, actually, with Hamel Hussein, with respect to like how you look at your data and how we can think through that. As I said, SQLite is perfect for logging. Later, maybe you want to like move to Postgres, MySQL, cloud-based solutions, if you want to like do some really, really serious stuff. But all we're doing here is essentially we're setting up our local database here, and then we're logging to it. And the rest, when we have our chat with model, and the rest, the Gradio interface, the imports, we're importing SQLite, right? The rest is the same, okay? So now, without further ado, why don't I do that? Okay, so let me just make sure. Okay, I already have. I'm just going to remove. I mean, when I was making sure this actually worked before, I did that. So I've just removed the database from before, and we'll see in app.py that this is the code I just showed you. So we have the setup of the database, chat with model where we log, then the Gradio interface. Okay, so Python apps app.py, and this once again gives me something local. So what I'll do is that's zoomed in. Hey, what's up? Not too much, just hanging out in the digital world. I do love the sense of humor Gemma and Gemma models tend to have as well. It's lovely and cute. I'm teaching a workshop with my friend Ravin Kumar, who works at DeepMind. You're part of the workshop. That sounds fantastic. I'd be thrilled to participate. Okay, cool. And we get a nice little party emoji at the end. So I'm going to leave it at that for the time being, because I do want to now show you how we can just look at the conversations. And the way, there are so many ways you can do this. The way I'm going to do it is with a really cool tool called Dataset, built by Simon Willison. Look, if you don't follow Simon Willison and check out what he does, I deeply encourage you to. He's one of the most interesting and exciting. And if you think I'm energetic, check out Simon Willison. Him and Peter Wang are like two of the most way more energetic people than me in the space. So it's a powerful tool for browsing, querying, and exporting SQLite databases effortlessly. Also, if you work with non-technical people, it's a wonderful tool for non-technical people to explore data as well. And actually, Simon's currently really excited, the past couple of years, about a lot of people working in media and journalism using Dataset to explore, do data journalism, essentially. Okay, so let's now jump in. And the way I do it is it's a command line utility. And I have this, so I call dataset chat log. It'll just start up a server, which I can jump into here, and we'll see I've got 3 rows in 2 tables. And very, very cool. And these are the 2 conversations. I'm not sure what the 3rd row was, but you can see I said, hey, what's up? It has the response, has the timestamp, has what I wrote about teaching with Ravin, and then the response there, which is super cool. And you can actually view and edit SQL yourself. You can check out the CSV. And I'm just going to export the CSV. And I just wonder if, Yep, I actually want to download it. That's cool. And what I'm going to, amazing. So now I have it as a sheet. Okay. Now you can put this in a Google Sheet or something like that. But the reason I'm going to show you this, and this is not, and I'll link to some of the videos I have around this type of thing. But what you can actually do, let me, okay, I won't in the spirit of saving time, I won't do this. But what you can do with domain experts as well and subject matter experts is now add a couple of columns to +1, -1, right? You give it a thumb up or a thumb down. And this is part of your iteration. So once you done your observability, looked at your traces, you can then evaluate and then take that back into iterating on your prompts, fine tuning, embeddings, whatever it is. You may want them to give reasons to do it as well. So maybe I'll say this wasn't a great response because X, Y, and Z, or it was a good response because of these reasons. When you do these types of things, and this is far outside the scope of this workshop, these types of analyses you can also use to start building an LLM as a judge as well. The other really important thing about writing down the reason you've given it a pass or a fail is it actually makes you think about why you think something is good or bad. A lot of the times these decisions are intuitive for us, but one of the great things about working with LLMs is actually having to formalize your own sense of robust thinking in order to give it instructions how to do what you'd like it to do. So that was a brief introduction to using dataset for exploring. I do also just want to add, this is a slide from the first workshop in the course we teach. Essentially, what we've already done and what you've done, this is so cool. You've allowed a user to interact with a front end. Now, all there is here, in the course, we have some form of context enrichment, which we're not doing now, but we have an LLM API call. We log it, we monitor it, and look at your data. And these are all the tools that we've used. Oh, let's delete OpenAI. Just jokes. OpenAI is currently deleting itself. I didn't say that. Okay. Damn, man. So we have a user, then there we've got a Gradio interface. Now we haven't used Llama Index. This is what we do in the course, but we're using Gemini here, logging with SQLite, monitoring with dataset, CSV, Excel, these types of things. So why is all of this important? I forgive me for repeating myself, but AI systems we're building systems, not just playing with models. We need observability and tracing to build trust with our systems to understand what they're doing. Logging interactions makes debugging, iteration, and improvement possible, which lays the foundation for deeper evaluation techniques in upcoming sections. So without further ado, I'll hand back to Ravin, and we're going to jump into actually thinking through our zero-shot classification now and evaluating our models using vibes, testing different prompts and seeing how well they work. So, Ravin, do you want to take it away?
Yeah. In terms of vibes, actually, I want to get a vibe of the room. Hugo and I were talking about two ways we could run this live stream. One of them was, and I'll give you the two options. Um, the next series is going to be interactive, where we're going to be actually building this basic classifier from vibes through repeatable evals to final evals and inference. But we could do it in a way where Hugo and I hand it to you folks to let you try it out, and then we pass it back and forth, where you have some time to work and then we work. Or the other option, which is option two, is Hugo and I can just try and live code it together. So do people want the let's say classic lecture style where you or exercise, let's say PyData tutorial style where you do some coding and then we come back, or do you want it where we live code it? I'll take votes over the next 30 seconds. Let's
Great.
let's see what the
And
people want, Hugo.
do we want people to vote in YouTube? Oh, sorry, in Discord?
Let's do Discord if we can. Although
Great.
we'll monitor YouTube just in case
Yeah,
it comes up.
wherever it's easiest for you to.
Yeah. So would you rather do it yourself, option one, or would you rather watch us code it up live, which is option two? All right. I'm currently seeing a strong bias towards live code, so it might be option two. I've got a couple people coming in Discord, so let's see if we sway it. But currently, live code seems the way we're going to go about this. So while we're getting the last round of votes, I want to say the notebooks are all in GitHub, and we have two versions of the notebooks. We have one where the answers have been completed, so you can have a reference there. And we're now going to be. It sounds like live coding is the clear winner, which is watching you guys will be live in my head. Okay, we're going to be live coding in the uncompleted notebooks. So I'm going to be talking and coding at the same time. My brain sometimes short circuits when I try and do this, but Hugo and I will go back. I think this is going to be a. And I didn't even talk to Hugo about this before we did this, so this is a little bit of a surprise to him. But I guess he knowing he's a chill guy, we're gonna roll with it.
Awesome. I'm excited. I don't even know what's happening. It's great.
Okay. So, like I said earlier, we're going to be building a very basic LLM app. It's not going to be the fanciest thing. It's really the Vegemite and crisps or peanut butter and jelly or basic children's meal of apps. And what it is we're going to try and get an LM to classify whether something is an Australian football team or whether it is an American football team. Um, uh, this is an important thing you see on the web all the time. You end up with text sources. They could be some website. They could be something that gets sent to you, and you have to know whether it's an email or a blog post or whether it's about one topic or another topic. It was actually a very classic data science tutorial. Hugo and I are old enough, if we date ourselves, to have gone through the first data science wave where text document classification was a big thing in 2014, 2015.
I'm just
And
glad we're not doing sentiment analysis anymore, Ravin, to be honest.
we moved on. Yeah, so
But
at
I
the
do, I
time,
do want to reiterate that, as I said before, people focus on the generative aspects, but the machine learning aspects of these models, the in-context learning, zero-shot classification are so cool. Sometimes they're prohibitively expensive if you're trying to scale something with, serious vendor APIs. Having said that, now we're using smaller models for this type of stuff. There are huge gains to be made there. So don't fall into the trap of only doing the sexier stuff. This stuff is incredibly powerful and useful.
to that point, Hugo's these models are very, very flexible. So while we're doing, like Hugo said, a classification app, all the fundamentals of the Grad.io app that you saw and what we're going to be talking about can be applied to any sort of AI app. We're just using this as a a hands-on use case. So instead of Hugo and I theoretically talking about the AI app cycle the AI app life cycle, we can code it by hand. So what we're going to be doing, let me pull up a piece of text. Let's say I have a piece of text like the one here in text sources, and it just happens to be this text that we see here. The basic question is this about an Australian football team or is this about an American football team? Um, and let's say I have another article such as this one. Is this again about an American football team or is this article about an Australian football team? You could easily imagine that if you're, let's say, a news company or you're serving news across the globe, you'd want to localize and you'd want to know what the text sources are about, for instance. So, like Hugo said, we're going to use an LLM model, Gemma 2, as we alluded to earlier, and we're going to just try using that to see how good can it do in the task in this particular task. And so the first thing that happens often with LLM models, and you see this on the internet as soon as a new model is released, there's this thing that we call vibe testing. A lot of people get their hands on the model, they try it out, they try different use cases, and a lot of, let's say, feelings come out of whether this model seems like it's a good performer or not. This may sound very, very ad hoc or hand wavy, but the reason we bring this up is I want to reinforce this actually is a very good way to start using these models. Already in this chat, I think I saw a couple questions. Is Gemma 2 good at this? Is Gemma 2 good at that? To be frank, the best way to find out is to just try it yourself and see what works and what doesn't work. So what we're going to do is we're going to fire up Gemma 2, and I'm going to fire it up at a command line because Olama has a really nice command line interface. So if you're following along with me, you can either do this. I'm going to do this in the notebook interface because then I don't have to share screens again. But you could do this in a terminal. Let me go to my launcher.
But yeah, it's Jupyter Lab, right?
This is Jupyter Lab, so I have access to Python notebooks and terminals. Um, I'm not doing anything in Python here. I am doing everything in my what is essentially forwarding from my local terminal. So if you're following along at home, whether you're on Windows or Mac, open up a terminal. You don't need Python running at the moment, but we're just going to type in, the first thing actually I'm going to do is to type in Olama run, and then I'm going to do Gemma 2 for this to specify the model family. And then I'm going to put in 2B, which specifies the 2 billion parameter model. There are other sized Gemma models. There also is, I'm forgetting off the top of my head. I should have these memorized. I know I think there's a 9B and there's a 27B in the Gemma 2 family. Actually, just to refresh myself, I'm just going to go to Gemma Olama and just look it up. Gemma
Someone
2.
also asked, are we doing anything multimodal today? And I said no, but can you tell us about any of the multimodal stuff you got going on?
Yes. So today we are not going to be doing anything multimodal. For those who are unaware what multimodal means, just in case, um, modes means the type of inputs that models can take. So the most classic mode is text in. Um, that's the model that we've been interacting with for quite a while now. But very rapidly, a lot of organizations, including Google, followed up with models that could take in images, models that can take in video. So I could I'll give you a quick demo just so you can see one. Let's copy. Let me go. Actually, let's
I'll go. Are you going to show us in studio or something?
I will. I'm gonna grab AI Studio. Let's just do that real quick. Let me show you a Gemini multimodal input just so you guys can see what that looks like, but then we're gonna switch back real quick. This is AI Studio. It's an easy place to try out all of Google's models if you'd like to. I'm gonna grab some sample media. I'll go here.
And while
Uh,
Ravin's doing that, I'll just say, please do check out Google's AI Studio. Ravin says it's great. He believes that. He also has a financial incentive to say that. I have no financial incentive to say that, and I think it's awesome and use it all the time. So please do play around with it, and you can play around with temperature and like you can do all types of cool things, and then do it immediately, get rapid feedback, and then start building it in code yourself as well. So really fun workflow.
So at that point, let's do a Vibespace eval on Gemini and AI Studio. I have a picture of something here. Let's say I have no idea what this is. I'm an alien, and it's the first time I've ever seen whatever this object is. But I have an AI that can help me out. I type it in, and in this case, Gemini 2.0 Flash will tell me that this is a picture of a sea turtle that is swimming in the ocean. Seems like it's a green sea turtle. This is a classic case of multimodal, and let's say a multimodal vibe check, because I just have a random image. I'm just checking if this model can respond sensibly, and it seems like it can. Now let's try something different. I'm going to go in and I'm going to select Gemma 2B. So let's go here. And you're going to see that my image disappears all of a sudden. I can't get to this image. The reason is the Gemma family of model is the Gemma 2 series of models are not multimodal. The Gemma 2 series of models are just text in, text out. There are, which I can get to in the side if someone has questions, let me know. There are multimodal versions of Gemma. One of them is called PalyGemma, but the Gemma 2 core family, the text and text models are not what we call multimodal. You can call them unimodal models in that they just take text in and they give text out. A question of why we're using again a small non-multimodal model. We wanted to make this tutorial as easy to run as possible, and this is a super fast model that runs locally. As soon as we start adding other bells and whistles, it gets a little bit more complex for you folks. So we're going to use the text in text out model to focus on the app portion of this tutorial. When we get to the end, we'll come back to how these principles can apply to literally any type of AI app that you're ever going to build. So what we're going to do, again, with step 2, is we're going to do a vibes-based eval to see whether our Gemma 2 model can understand the difference between an Australian football team and an American football team. So I'm going to go in here, and I'm going to say, let's just say Green Bay Packers. Is that an American or Australian football team? So all I'm doing here is I'm taking something that I know is obvious to me. I lived in Wisconsin for a while. I know that the Green Bay Packers was an American football team. But I just want to quickly understand if the model understands that. How good is its performance on this particular prompt? I'm gonna hit enter, and it looks like it got it right. Hugo, what's your favorite Australian football team?
So I'll answer that in a pardon me. In a second. I am interested. So the vibe is good, but if I were building a machine learning model or actually wanted to build something a bit more robust, I wouldn't like that output.
That's
I'd
a good
want
point.
it to, I'd want it to say American, just American or Australian, right? So at some point, maybe we want to engineer the prompt to figure out if we can just get that coming out, right?
Yeah, okay, that's a good point. You call it that this would not be a very nice classifier to use, because it's outputting a lot of extra text. It puts American in the middle. We don't need any of this extra information. So let's try doing what's called prompt engineering. You've probably heard this term a lot, or at least a couple times because it's been on LinkedIn and all over the place. Um, it's just a really fancy way of saying, let's just try different ways of asking the model to do what we want it to do. I want to highlight that there is this concept in models that I hear, especially in my day-to-day working with these models. It's called instructability. Um, I think if you folks have worked with models and as you continue to build AI apps out, you're going to notice that some models are quote unquote more instructable than others. It's kind of like people. Some people are easier to give instructions to or work with than others. I think Hugo is a very easy person to work with, which is why him and I are doing this tutorial. I'd say there's other folks which require more handholding or more instruction, and you're going to find the same with these models. And so this is an important thing that I always do with these vibe checks is I try and get a sense of um, how much understanding does the model have? In this case, with classification, but it could be with reasoning, it could be with math, it could be with all sorts of things. And I also try to get a sense of how instructable they are. So let's try that here. Um, Let me rewrite this prompt just to Hugo's point. And I don't have my nice terminal commands, skip commands in IPython or Jupyter Lab. So let me do this the slow way. Apologies while we get through a small terminal here. Okay, I'm gonna say only output, or let me say, is this an American or Australian football team? Only output American or Australian. And I misspell Australian every fifth time, so you're going to see that. And we're going to put a colon there, and I'm going to say Green Bay. Whoops, Green Bay Packers. Okay, that actually looks much better. Quite happy with the performance from a small model. So, Hugo, going to throw it back to you. What's your favorite team?
Yeah, funnily, I don't actually follow football so much, but a game I do watch every year is the State of Origin, which is New South Wales versus Queensland. And it's Go Blues, so New South Wales Blues, NSW Blues, or yeah, New South Wales Blues. Let's
All
see
right,
NSW if it actually.
let's do that. NSW Blues. Ooh, did not get that one. New South Wales. All right.
Amazing.
Not doing so great on these ones. So now we're getting a sense of how this model is working. In some sense, sometimes it gets it, sometimes it doesn't. So let's try modifying this a little bit. Only output.
And would it be, we don't have to do this now, but would it be worth just showing my mistake and getting out of this run currently and doing Olama run Gemma 2B if you have it here?
Yeah, let me grab that. Before we get
Because when
that, you
doing
saw that.
vibe based, we can just get a vibe on if a different what a different model looks like.
Oh, on a different model entirely. Which model? Oh, in Gemma?
Yeah, exactly.
Okay, so let me exit out. I might have to pull Gemma, so see how fast this is. So I'm gonna grab a different model real quick and let's see how long. I don't want to take too much of your time. Let's see. I'm gonna pull Gemma, and this is Gemma 1. So we have Gemma 1 and we have Gemma 2. If I type in Olama LS, you're gonna see all the models I have on my system. Currently I have a variety of Gemma models. I needed to save a little bit of disk space. Let's run Gemma 1 and you'll see what the difference is. Olama run Gemma. Now we're in a Gemma 1, Gemma TV. Now we're in a Gemma 1 prompt. Let's say which nationality team is this? Uh, American or Australian? And we'll say
Do the
New
Packers. Oh,
Packers? Okay.
do the Packers, and because that didn't quite work for me when I told it to specify. Ah, okay. When I said only specify American or Australian, or yeah. But it may work for you now, and in which case we're seeing in real time the flip-floppiness of LLM behavior as well.
I mean, let's try this. So you're already seeing that to get this, I'm typing in a lot more strings and it's
Yeah.
not there. So this L Gemma
Just
1
one.
is a lot less instructable, I have to say. Like, and you're seeing it here. The model at the time when we released it was a good model. But quickly, as we figured out internally, there was a lot more we can improve on it, and that's a lot of what you're seeing in Gemma 2. You already can see a big difference in the vibes between
Well,
the
yeah,
two.
there's also a joke that like GPT 4.5 is actually quite amazing at the moment and very strange and curious and creative and funny. And people are like a bit meh about it because like the delta isn't quite obvious, right? Just as now Gemma, it's like, oh, it can't even do that. And it's like, wait, this was like
Amazing, yeah.
yeah, this was absolutely amazing. And just quickly, for anyone who wants to play about a bit more around with Gradio, what an exercise for the reader is to build a basic app with a Gradio front end where you put in one prompt using Olama, but it actually pings several different models. And it will give you two outputs, for example. You can build that relative. You might need to do some multi-threading or something like that, but you can do that. And you can actually have three or four models. You put in one prompt and see the output from four different models. Super fun stuff.
It's also super helpful, right? Because I think a question that came up was how do I pick a model? This is the first step in picking a model. There are so many out there, um, and especially for more complex use cases, it's not actually clear whether a model is going to work for specifically what you need it for or not. That going with these vibe-based evals, trying it out and seeing whether it's giving you the performance you need or not, really is a good check to see whether you should invest more time with that particular model, or even whether your app is going to be feasible or not. Um, and also the other one is whether things have gotten good enough to where your app is feasible or not. I mean, the way like Hugo said that we're moving, things that are challenging a year ago become quite possible a year later. Multimodal is a really good example of that, multimodal understanding. So you may have a cool app idea now, and the technology isn't ready yet. But you do another Vibespace eval in October 2025, and you find out that it is much closer than you thought.
Exactly. Mr. Me has a question. I'm not sure I quite, but he asked, how does Gemma 2 handle unknown words?
Um, so all LLMs I think handle similarly. They have what's called a tokenizer, and so this is going a little bit more into the model internals. So I'm going to do a very light pass here, and then maybe we can come back at the end. LLMs technically don't understand words. They understand these things called tokens, and the tokenizer splits words up into words or images or lots of things actually now in multimodal models into little chunks, and the LLM operates on those particular points of chunks. Now, the second part, which is hard to understand or hard to point out, is how does it understand? The meaning of what LLM understanding right now is a big debate in the community, whether they what it means mathematically or what it means philosophically. What I can say with open models in particular is, which is a very research exercise you could do, and maybe this will be a follow-up session, is because open models are open, you can actually inspect the internals of what is going on in them at the tensor and mathematics level, and you'll see exactly how they um, they interpret and at least calculate their outputs with unknown words. So it'll be good exercise, but outside of the scope of an apps tutorial and more in the scope of a research and tokenization tutorial. But I'll come back to that, and I'll provide some links so you can get the Gemma 2 code, for instance, and go and do the deep dive yourself.
Awesome.
And
Thanks, Rick.
yeah, definitely call out if people have questions because I can't see either of the
Yeah, yeah,
chats.
yeah.
So
I'll let you know. Absolutely.
awesome. Okay, so we did a Vibespace eval here. We see that Gemma 2 is actually more Gemma 2 2B. I know it's confusing the model iteration and the parameter size. But Gemma 2 2B is more instructable than Gemma 1 2B. So let's go ahead and just say this is a good candidate. At least we're going to keep moving forward with it. Again, later on, you're going to have the chance, or we're going to have the chance to try out different models. And we're going to stick with the 2 B model right now because it's just faster. Um, what we're going to do is we're going to jump back into our notebooks. Let me get back here. We got some results. We started prompting. And so for a recap, it's really fast to just do this. Like we literally just got some vibes, not even just on one model. We got some vibes on 3 different models on 2 use cases in about 15 minutes there. We had the Sea Turtle use case in AI Studio, and then we had our Australian vibes check here. I think this is again, this is a really quick way for you to take your app idea and just try whether it works or not without having to install entirely new models, without having to waste a lot of time thinking really hard about a lot of other stuff. It just gets you a lot of traction and a lot of data really fast without having to think too much about things. And to Hugo's point, if you want to level up this exploration to the next step, or sorry, if you want to level up to the next level, you can use a front end like Grad.io and actually vibe check 3 or 4 models at the same time. I have to admit, sometimes I'm a little lazy or primitive, and I just copy and paste the output into different models and just do it that way. But I think people like Hugo that have LLM harnesses where they've got multiple models running at once are operating much more efficiently than I am. The second I'll say is prompt engineering actually is quite a valid skill. There's a big debate, I think, sometimes I see on LinkedIn whether it should be a job or not. In the sense that LLMs are tools, the people that are able to get, get the outputs they need from these models faster, it generally is a valuable thing. You get to results faster, you'll know what works, what doesn't work. So I encourage you to, even if you're not building an AI app, just play around these models and get a sense of how to get what you need from them, because then you can just use them as the very useful tools that they actually are. So I'm a big plus one to folks that have really good prompting intuition. All right, that's where you're on vibe check evals. I'm gonna pause for about 15, 20 seconds here, see if any questions come in before we move on to the next topic.
There was a question on Discord which I missed, sorry, from Panda. Thank you for it. Around 4 minutes ago. Is part of the problem with the model figuring this out due to the constraint of the prompt, forcing the model to respond to a more limited number of tokens? And I think maybe that was around trying to get it to say American or Australian or.
So I'm trying to interpret the question here. I think there's a technical answer and there's a more vibes answer. Um, most LLM frameworks, LLM stop generating often because of two things. Just generally, one is the output was called an out of or end of sequence token, and the framework like Olama knows to stop. The other is that either there's a hard constraint in the model or a constraint in the framework that it needs to stop generation after so many tokens. So to that point, one good thing to check, and we'll talk about this at the inference notebook, which is notebook 4, is what the constraints are for inference of your LLM and of the framework. But for now with Gemma 2B, another reason I picked this very short answer is so we could say well underneath that prompt limit. And so in this case, it's just a matter of Gemma's instructability, for instance. As we saw, Gemma 2 was much more instructable than Gemma 1 in this particular case. All right. With that, I'm going to jump into the next notebook. So to recap this, let's say we ran some vibes evals, or actually we definitely did run some vibes evals, and we're feeling like Gemma 2 2B is a good candidate for what we want to do. Now, these vibes evals were great, but as you can tell, I was kind of just making up on the spot with Hugo. We were just kind of winging it. Not really something that's easy to repeat because tomorrow I'm going to forget what I typed in, and it's going to be manual to type it in again. So good for a first check, but not great when you need to start iterating more often. So what Hugo and I both jointly suggest, as do a number of other people, is you want to move from vibes-based evals, or once you've graduated from vibes-based evals and feel like you have something that's a little bit solid, you're going to want to start moving to repeatable evaluations with an eval harness. So there's two parts to this. One of them is evaluation, and one of them is the eval harness. So we're going to cover both. Let me talk to you about, again, how Gemma, or how to use Olama for prompting in Python. And then Hugo and I are going to tag team on this one, showing you an eval harness that I built in the notebook. And then Hugo's going to show you how he built a really cool eval harness in Python code. I guess they're both Python code. In a Python standard module, and how that is the more deployable solution. So like you saw earlier, we have a Gemma model, and we're going to be using Olama in Python to get responses out of it. So here's our hello prompt. Now that we're past the hello prompt, we want to see how good the model is at predicting team names. And now I've grabbed every single, or what I believe is every single AFL club and every single NFL team. And because I've segmented them, I know what the answer is, that these should all be Australian Football League clubs. This should all be National Football League clubs, or at least American National Football League clubs. I can build an eval map. And with a Python with a Python loop, a couple for loops here, and a prompt, we can see how good of a score we get. So what I'm doing here is I have my prompt, I'm getting my response, and then I'm going to check whether that team matches the nationality that it comes from. If it does, what's going to happen is I'm going to get a true, which is going to evaluate to a 1. If I don't, I'm going to get a false, which is going to evaluate to a 0. And what I'm doing here is I'm taking the mean, which is going to give us the average. So let me actually for a second just remove the mean so we can see the scores. Oh, of course, live demo. Technically, I don't need the print, but we'll just live with it. So from this print statement here, we're starting to see all the things come out. This prompt, admittedly, with a little bit of testing prior to this lecture, I was going to say, we originally were going to have you folks write the prompt and mess around with yourself and make a little bit of the mistakes I did. But I had done a lot of that before, in the last week, and I found a prompt that worked quite well. And here we see that we get what is a 100% true rate. This model nailed every single one of these. When we give it the team name, the location, whether it's West Coast or St. Kilda or Richmond or Detroit, and the name, it does a great job of telling us which team it's from. Okay, that's great. But now we want to move away from a notebook and we want to make this a little bit more repeatable. So Hugo, I'm going to let you take it away and talk about this code block here.
Definitely. Thanks so much, Ravin. Let me share my screen. And can you see my VS Code again?
We can see your VS Code.
So now,
before we get I want to point out Hugo is doing the same thing I did. He's just using the VS Code IPython notebook runner. So if this is tripping anybody up, I want to promise you that they're the same. They're the same thing. We just have a different preference than ID, but that's totally okay. But anyhow, go ahead, Hugo.
and funnily, I'm a huge fan of Jupyter notebooks. And look, I actually, when you opened Jupyter Lab, I remembered it must have been 2014. I was at SciPy when it was in Austin, Texas, and I bumped into Brian Granger, who is one of the creators and founders of Project Jupyter with Fernando Perez, who built IPython. And he said, "Oh, Hugo, do you want to come and just test something for me?" And I was like, "What?" It's like this new thing we're working on called Lab. And he stood next to me. He's one of the loveliest guys in the world. But I was so nervous because I was there, like playing with one of the first versions of Jupyter Lab, not even sure what I was doing. And he was watching me. When someone like Brian Granger is watching you write Python code, it can be very disconcerting, even though he's the loveliest guy in the world. Having said that, I do love Lab. Because a lot of work I do and courses I teach, I use code spaces for in GitHub. I'm really a VS Code native as well these days. But all that having been said, we want to make this repeatable. Ravin's just done this in a notebook, and whether you can productionize notebooks or not, I'm not here for flame wars, really. I don't know if Hamel's on the call, but maybe he wants to chime in, or Jeremy. But now we've run it in a notebook. I want to make sure that this process is repeatable and scriptable. Okay, so what I've actually done is I've executed the following cell, which you can do. It's kind of like the code Ravin wrote above, but it does the predictions using Gemma 2B for you, but it saves them all to a file, and it saves them to this traces.csv. And you'll see we have now team name, we have the ground truth, and then we have the model output as well. Now, after we do that, let's I've written this eval harness script, and essentially what this does is it takes in the team name, ground truth, and model output, and then compares them and calculates the accuracy. So it's essentially just a script version of what Ravin did, and I literally just executed that. I'm gonna delete the output of it so we can run it again and see what's up. But it's essentially just gives me this little command line which allows me, and I used argparse to be able to write this, which is a lot of fun. But we've got Python eval harness.py calling that. I'm telling it what the input data is as the traces, and then I'm telling it what I want the output to be. And I'm actually going to change this slightly to Gemma 2. Okay. because I might do Gemma 1, and we can see model accuracy 100%, the same as Ravin got, and 50 out of 50 correct. And now if we look at the scored results, we see I've even got little emoji ticks, and that's just for fun. I don't necessarily suggest you use emojis in production. Having said that, it's nice to have a laugh every now and then. Great. So, the other thing I wanted to show you here, though, and we did go through this, but this is when things got weird. When we were preparing, Ravin and I were preparing this async, and I literally had just had that instead. Okay, so I ran that, and everything looked okay. So now I'm using Gemma, not Gemma 2, right? And the reason I'm doing this is to show you what what happens in the eval harness, specifying the clubs. Well, let's execute that. And now let's see Ravin's cell. And look, yeah, these were the things I get. The context does not provide any information about the team being referred to. The context does not provide any, and I was like, what? And so on. So we get some of them. And we can see it looks slower as well, actually. But why is it 0, even though it said the team is Australian? Because it didn't just say Australian, right? We asked it to say Australian or American. This Gemma got a 0, okay? Which is important to recognize. Now I'm going to save these to different file, and we'll see traces Gemma. Oh, it's still running. Okay. It's nice. It's kind of fun watching the output. Zen and the art of watching LLMs talk to you. I used to talk about Zen and the art of watching the epics roll on by in deep learning. When you get into like a meditative state of just like training deep learning models and watching the epics and watching your loss go down and what happens with your accuracy. So yeah, look, this is the model output here. Great. Who would have thought that looking at your data would help at all, right? As opposed to building multi-agentic architectures and multi-turn conversations. But having said that, we can see that this model's not doing what we want it to do. Okay, so we've seen that, but were we to want to compute this using our harness? How would we do that? Let's go back up here. And although I've got a new keyboard, I didn't realize I got like a 60% one, which has no arrow keys, and my keyboard bindings. Anyway, so I want to now output that to Gemma, and this was data traces Gemma, I think. And we see model accuracy was 0, good, what we expected, and 0 of 50 correct. Okay, so let's now look at, was this traces Gemma? No, I want scored results Gemma. Yep, and we can see we've got an X for all of them, right? So the whole point of demonstrating that was once you have a way of evaluating your system performance, you can then put that into a script like this, which then you can automate the running of. So we're not going through this, but before, and let me actually go to this slide. What we're talking about here are some form of testing, essentially, not quite yet. But we can perform tests, and these types of eval harnesses we can integrate. So whenever we push something to a repository, we can run the harness and see what's up as well. And we want to be versioning these things also. So these once again are the types of things that we use in the course. We've got a great question. Would it be possible to forcibly constrain the output to either Australian or American, just in case the model chooses to give a more verbose output. I love that. I love that so much. The way I do that is like some form of just grepping, like seeing, does it have Australian or American in it? And if it has one of them, if it has one of them and not the other, use that. If it has both of them, you probably want some form of error mode. But I love that. And that's also speaking to just using more classic tools as well. On top of that, and actually I've been taking Jason Liu's RAG course on Maven, and something he's really bullish on, and I love it, is in information retrieval pipelines, using classic techniques, such as BM25, whatever it may be, for information retrieval, and not using LLMs at all, then using generative models to give a generative output. But what that allows you to do is to immediately test like precision and recall on the information retrieval part without worrying about all the nuances of the generative aspects. And that actually ends up being a lot cheaper, especially when you're starting to evaluate them. So you can see that having two possible or three possible outputs, American, Australian, and none, is really what you want. So yes, you can forcibly. That was a long way of saying yes, you can definitely do that. So just to recap where we are so far in the system, within the system, we've built the MVP system with models, data, front end, database. We've done our zero-shot learning, our text classification to classify footy teams with Gemma 2B. We've done our vibe-based evals. We've also done our repeatable evals now, building a harness, both in a notebook and in a script. And this is something you can automate. Like you can actually try to just use GitHub Actions to, in a branch, if you push a new model to it, you can automate the running of this evaluation, and you can create a Discord bot with it. Once it's run, it'll ping you on Discord, or something that'll send you a text message, or something like that. And if you don't know how to do those things, chat with an LLM to find out, actually, which is one of the great things about the world right now. Now we've got repeatable evals, a way of testing accuracy. Ravin, it's time to think about optimizing, right?
Yeah. Before we do, I want to reinforce like one point in the repeatable evals. So I think when people build AI apps, we think a lot about the model. Like, am I using a new model? Am I using this latest one? Am I using one that I used before? One that has certain parameter size? I think a lot of people think about the front end, which Hugo showed earlier. Am I building it in Grad.io? Am I building it in something else? But part of what Hugo and I want to reinforce here is that you also want to think really hard about your eval set, the eval methodology you're using, and how you're making that thing repeatable, which is that eval harness. I think this gets glossed over a lot. It's not the fun or sexy part of working on AI apps, but if you have these, it puts you in a really good spot, just as Hugo demonstrated just now. A year ago, let's say pretend like the world only had the Gemma model. You would say, I really needed a classifier. I have to use an LLM. If you just by doing the Vibespace eval, we could tell things weren't going right. But if you've taken the time to build the eval set and build an eval harness, when a new model comes out, like Hugo just showed, it just takes you can do it automatically, but even if you run it manually, it just takes you 10 minutes at most to rerun that eval and see how much farther the performance has gone on your app. And what this means is when you're in a business, let's say you need to build an app that's going to be going to customers, or you're building an app that's internal to your company. You're going to be able to say that, hey, when we use this new model, you're going to see this much more performance from it. This many more users are going to be happy. This many more things are going to be right. The Vibespace eval is going to be good to give you a sense of what that's going to be, but the eval harness and eval set that Hugo showed you is going to give you that exact number. So it is very worthwhile to think hard about your eval set, your eval harness, and your eval sort of methodology. With that, you're in a great spot to then move to optimize, which we're getting to in a second.
We have a great question as well. Can we integrate ML Flow to track the tracing and capture the performance of evaluation? I haven't used ML Flow recently to be able to answer that. I think the answer is yes. My bias is there are other tools such as Metaflow, which I've worked on, and I've worked with the team for a long time, and I still can consult with them. But yeah, there are lots of tracking tools like MLflow. Metaflow, I really encourage everyone to check out. But Opic from Comet is really interesting. There are lots of ones that integrate with OpenTelemetry as well. Burr, which Stefan, my colleague who I'm saying his name like he's Dutch. Stefan. He's actually from New Zealand, but he has a Polish last name, but he was born in Mexico. So he works on Burr, which is a fantastic framework. So the short answer is there are lots of tools which will help you with this, but if you use MLflow, I'm pretty sure it'll work. I think part of my bias is I love Databricks for a number of reasons, but I also don't. And like it's the big dog thing. I'm an underdog type of guy, particularly coming from Australia. So MLflow doesn't need more users if you ask me. So go and try other tools. Weights and biases and has a bunch of cool stuff as well with Wave, I think. So and Mr. Me has a question. Mr. Me says, I know in one of Ravin's presentations he mentioned maintainability of lifecycle. Would using repeatable evals be part of that lifecycle?
Sure, I'll take that. Absolutely, yes. So I think one other point I want to mention about AI apps is the AI part is really cool, but you have to remember there also is the regular app part. You could very easily break your app by pushing a code update to your front end that garbles the text. You could break your app by putting in a dependency that is wrong, right? You still have all the problems that you can have from regular software engineering. So, you've deployed your app, it's on some version of Grad.io or NumPy or whatever you want to use, or Olama, who knows. Um, and you just want to upgrade it for the latest security update. If you have a repeatable eval, you can be darn sure that that change doesn't break the AI part of your app because it happens all the time. I see this, people are like, I'm not changing the model, I'm just changing a software library. But suddenly the AI part just becomes wacky. Um, Eval harnesses are essentially end up becoming like unit tests. So another really big reason you'd want to use this, especially if you have a production grade app. There were two other questions that were outside of the eval harness point, but I'll get to them. One of them is I'll back to the forcibly constrained output. There is a thing called constrained decoding. It's a tool that also is often used to force, like, let's say JSON output, but you could force any arbitrary output from an LLM. It is a very useful tool in the LLM toolkit. So I'll come back to constrained decoding later, but that is the current thing you should Google or search for if you're looking for constrained output. Um, and then there's one other question on Discord. It has to do with thinking models. So I'll come back to this at the very, very end. But if you've lived in the AI ecosystem the last 2 years, it feels like every 7 months there's a new wave of things. So it was text-to-text models that we talked about at the beginning. Then it became multimodal models. I'd say mid last year. Then it became agents, which every time I mention this, Hugo is like, "You're ruining the vibe by just saying
No, no,
agents."
no.
But that was the whole thing. And now it's also become thinking models. So we'll talk about thinking models at the very end. But it's this idea that if you give LLMs extra tokens or time to reason, the output becomes better. A number of benchmarks have shown this. There's again a number of empirical benchmarks have shown that it's better in certain categories, but you have to have extra inference costs. So let me take the thinking idea and question, and we'll work it into the notebook 4.
And let me just say, I love agentic vibes. What I don't love is people trying to build robust, reliable software to solve business problems currently using agents. And I've just linked to a lightning lesson I'm teaching with Stefan tomorrow called On LLM Agents, when to use them and when not to. And actually, I think they're incredible. I mean, I'm using deep research and a variety of things on a daily basis currently, which have a lot of agentic vibes. If I were building what I wanted to be repeatable, customizable, consistent software for a business, I would not use. I mean, tool calls can be really random currently, right? So having a bunch of LLM, so an agent is essentially a bunch of LLMs in a trench coat with tools, right? And some environment. It's very challenging to build reliable software with those types of things at the moment. That doesn't mean the space isn't incredibly exciting, but if you want something consistent and reliable, probably agentic approaches aren't necessarily the way to go currently, I think is my, not hot take, but my take. I also thought to add, I mentioned Metaflow earlier, and Ravin, you talked about promoting things to production. One of the lovely patterns I've seen in Metaflow that Metaflow makes super easy is essentially having challenger model. Like, let's say you've got your champion model in production, and there are other tools that do this, but it allows you to really easily like serve a new model to 1% of your users or even internally, and then be able to use your eval harness to see how it performs immediately. And then if it's doing better for long enough and you monitor it, works well, you can promote to production. The other thing that we're going to cover a lot more in cohort 2 of our course is actually you creating synthetic data in order to rapidly iterate on your model. So you don't even need to necessarily deploy it to production to be able to improve it. And there's a whole new world of that, which is super fascinating. I don't know if you've done much with that, Ravin, or thought about it, but I presume that you have in terms of creating synthetic data to evaluate your model performance.
It's actually funny you bring that up. I use synthetic data to evaluate the model performance of Gemma 2 as part of this tutorial. So I'm gonna say we'll put a pin on that, or put that feather or sorry, we'll put that away for a moment. We'll come back to it because I have a lot to say on synthetic data creation and thinking models, which is a little bit a part of that. Let me recap Notebook 3, and then we'll move to Notebook 4. And actually, we're also quite ahead of time. So I think we're gonna end up with a bunch of time for Q&A at the end where we can just talk about
Yeah.
other stuff.
But
But let's
before the recap though, because this should be part of there's such a great question
oh, okay.
by Harry Haran. How can we convince our manager about the importance of evaluation and continuous monitoring? Most of the folks feel like once the application is built using the models, that's the end. So the cheeky way of answering that is you can convince them by not monitoring it or evaluating it and seeing it degrade and start to fail. And then they'll say, why is this failing? And you would say, because we didn't prioritize monitoring and evaluation. Now, that's kind of like, I don't necessarily think that's the way to go, but as a kid, I put my hand on a hot plate once, right? I never did it again. Not because my mum told me to not put my hand on a hot plate, because I felt the pain. So there's something to be said for, learning by suffering. The other thing is to have this explicit conversation to say they're non-deterministic. We don't know what the input data will be. And so what we need to do is to keep an eye on it at the start to build trust with the system, and maybe check on it every half hour or every minute when you first deploy it. Then after a week, every few hours, then every day until you start to develop a trusting relationship with it. And so I do think speaking to the non-determinism, so the fact that same input, different outputs, and then the fact that you don't even know what the input will be a lot of the time, that you need a way to build trust with it. And the way to do that is evaluation and continuous monitoring. Those are the ways that I've approached it in my work. The other thing is whoever's leading these projects probably should be technical and understand these things as well. But maybe you're reporting into, a chief marketing officer and they actually aren't so aware. But I'm interested in your experience, Ravin, how you've thought about these types of communication skills and how to communicate the importance of this.
I would say I think at Google I'm quite lucky because the company has a lot of folks that don't know how apps and stuff are built even before AI. Google has a very strong culture of unit testing. So if we forget AI for a second, Google has a very strong culture of test-driven development and testing and making sure things are tested. It's part of the reason that Google services tend to stay up very, very reliably. YouTube is almost never ever down, nor is Gmail. But I didn't have this experience at the first companies that I worked with, for instance, that were non-software companies. It just took a little bit of, like Hugo said, some cheekiness of letting bad things happen and sometimes letting the pain happen. Sometimes it took me having to convince my manager up front and then telling him it's a part of it. And sometimes it took me just having to not tell my manager I'm doing it, but pad my timelines to include them anyway. To say, maybe I knew I could build an app in 3 days, but I tell my manager it's going to take 5 days just to give myself a day or two to build the test as well. So it's really just going to depend on the situation you're in and who you're working with. Um, to to for it's I'd say that's more of a, I don't mean to put it this in a bad way, but it's kind of more of a people problem than it is a technical problem at that point. You have to find
A
what works
lot
for
of
you.
this is that though, and Igor has such an incredible question that follows on from a lot of what we're talking about, which is building trust with evals. Do we want our system to work 90% of the time, or do we want it to work 100% of the time? Great question, impossible to answer in the abstract, right? So let me ask you this: if you were trying to, if your system was doing brain scans and trying to identify risk of stroke, let's say, you don't want false, like, you
False
don't want
negative.
false negative. You definitely don't want false negatives, right? Um, However, if your system is serving ads to creative ads to people, maybe you just want it works 80% of the time or 70% of the time, right? So it actually depends on what your end goal is, and what the business or medical goal is. Now, something this relates to, and this is something we talked about in the course a lot, is that when it comes to tests, rarely will all your if your tests are passing in an ML or LLM, sorry, in an LLM powered application 100% of the time, there's something wrong. That does not smell good if your tests are passing all the time. Whereas in classical software engineering, you expect things to pass all the time. So the conversation with software engineers about the space currently, about even should we use the word test, right? With respect to these systems, and how often they should pass is incredibly important to manage expectations. Do you have anything to add to that, Ravin?
And I think you're right. It is 100% context dependent. To be frank, in this app we're building, if this thing failed half the time, it wouldn't really matter because this is not really going anywhere. It's not going to be used in some critical scenario. But um, things that have big consequences, you want it to be right a lot of the time. Again, part of the reason this eval harness is really important because you're being really explicit about where it's passing and where it's not. Actually, this is actually a good segue into the next part of the tutorial, which I'll show you, which is where this application starts failing. So let me, I saw there's other questions, but let me jump onto that portion just so you can see it, and then we'll come back to the other questions. So let's say, for instance, we continue with our app. We know it works well now with the team name and the city, but now let's say we remove the city and you just get the name like this. You get crows, power, tigers, saints, eagles, and then down here we get some more stuff. We get Rams, Raiders, Giants, Saints is going to be somewhere in here for sure. And some of you listeners with sharp ears may already, or sharp eyes may start to see a problem. Let's go ahead and run this and see what happens. So I'm going to use it in Colab. We could use Hugo's runner as well. We're going to look at our accuracy at the bottom, and we dropped down to 87%. And the question might become, why did this happen? We were just perfect at it before. But if we take in and look, some of these things like suns, uh, that ends up being American. That seems suspicious. Saints here is Australian, but Saints here is also Australian. There is a US team called the Saints. And so if you just give it the string the Saints, suddenly this performance drops a whole bunch. So previously, our eval set really only covered, let's say, the perfect use case where you had these perfectly formatted strings that had the names perfectly made with the city, and it was easy for the LM to get it. And frankly, it's easy probably for anybody to get it. But if you ask somebody whether the Saints is an American team or an Australian team, and you can only say American or Australian, that is an impossible task. They're only 50-50 going to get it right. You have no idea what the answer is because there's literally not enough information. And so to the question about whether this is a good pass rate or not, maybe again, if you're just serving some ads about teams and trying to sell some jerseys and socks, like, you know what, not a big deal. We still got 87% of them right. We're gonna sell a lot of jerseys and socks. Not a huge problem. But if this was, like Hugo said, a brain scan, and you're getting 87% because there's missing information, that's a huge problem. You're gonna have to figure out what it's gonna take to bring the reliability of these systems up. So the eval set and the eval hunters tells us that percentage. Your business context tells you whether that percentage is good or not. Um, and the eval set as a whole is going to tell you how many cases you're covering in the possible set of inputs. And it's really all three of those that's going to give you the holistic picture of where you are in your AI or ML app. So I'm gonna skip the news article one. I'll tell you what it is and I'll let you run it at home yourself. Basically, if we had these data sets which are not team names, but they were the text sources that I showed you earlier. They were things like this, like snippets of text that have something that sounds football-like, and you just need to quickly tell whether they're an Australian team or an American team. That is that cell block that I just showed you down here. It takes in those text files, it runs them, and it tells you whether it's American or Australian. What I encourage you to do is an at-home exercise now is try these two and see if you get the same thing that I get. Then also go try add your own in. Go on the internet, go read a book, grab some text from somewhere, or type it in yourself, and see whether Gemma 2B is going to be able to correctly output whether it's Australian or American.
Also, generate some using Gemma 2B and see Gemma 2B, see what's up. Say, generate some synthetic news articles that are about Australia or America, um, and see what's up.
Yeah, get your hands on synthetic
Have
data
fun,
creation.
build.
So let's go through the recap. I think Hugo and I hit a lot of these points. I'm going to go through them really quickly. Evaling with vibes is a good start, but you're really going to want to get to repeatable infra pretty quickly. It's going to make it faster to rerun your stuff when you get a new model, when something changes, just to make sure things are great. As your project scales, you get more contributors. This way, they can just add eval sets, and they're immediately part of the eval check. And with vibes, it's, again, a good start, but it's going to be ambiguous in the future what you checked. Did you check all the edge cases? Did you check the core set of examples? Having a strict eval set and eval harness makes that very clear. Eval sets are just as critical as the app at the front end. They're often forgotten, and we got that question of how can you get your boss to or your team to invest in these. At least what I can leave you with, or the impression I can make on you, and I believe Hugo would agree with me, is you want to put a lot of thought into your eval set, almost as much thought as you put into your model, or even as much thought as you put in your model and your front end. So what we're going to do here is we're going to say we ran the evals for a model. We're perfectly happy with the way it runs. 87% is good enough for our use case. We're ready to put this thing in production. We're going to move to production data sets, unless Hugo, you have something else.
That sounds great.
That's it? Okay. And we're going to move to production and inference. So I'm going to go to the last notebook that we have. Optimization. And I should have retitled this one. I should have called this one, in this case, inference or production optimization, for instance. But let's talk
No,
through it.
yeah, and you're going to have to define inference, particularly when it's two people like you and me teaching, Ravin.
Yes. So I promise we'll get to that. Let me talk about what happens typically, and then we'll talk about what's in this notebook. I think again, a lot of people focus on the app on the front end. They get a local demo running. Let's say they even got as far as running some evals, which is a huge bonus, and they put it out into the world. Um, well, when you put it out into the world, there's a lot of other things you have to worry about, and one of them was that cost word that we brought up earlier. Running these apps isn't super cheap. Now it's getting cheaper and cheaper, and we're seeing the cost curves come down tremendously. But as some folks pointed out, they are still more expensive than traditional classifiers. And especially if you're running a big models, they still cost a pretty penny to run a lot of inference over. They also sometimes on the user side, if they're larger models, and as you saw earlier, sometimes these things take 10 seconds to respond. It's not the best or smoothest user experience with certain hardware combinations or certain model combinations. So once you're ready to deploy your app, and even once you have your app in production, it's worthwhile thinking about how to make it smoother, faster, cheaper, and better. So
I
what
will
I'm going to do, go ahead.
link to Modern Bert in the chat. There are so many cool smaller models that you can play around with for different tasks as well. When thinking about, text classification and those types of stuff, maybe you want to use a basic classification model that you've got from the Hugging Face Hub or whatever it is, right? There are also, smaller embeddings models that maybe you want to use instead of, the current state of the art.
Yes, there are lots and lots of models that could provide better inference time optimizations that once you have your eval set, you can check. I'm going to be showing, we'll show one example here, and then we'll show you how to think about all those different ones in a second. So what we're going to do here is we still have the same task that we did before. Let's say people are providing their articles through the Grad.io front end, and we want to tell whether they're American or Australian of the football team in nature. Here we have, let's say it's an article about a journey through time, the achievements of someone called the North Melbourne Kangaroos. I think as a human, we get a good sense of where this is, what this is going. But let's show you what's going to happen in production. So this time I have the same loop that we had before, or the same function that we had before, but I had added one more thing. Let me run it, and then let me show you what that one extra thing is. Oh, gotta make that. All right. So we're going to run this, and you see a number come out. So we get the Australian string, which is probably what we expected. I assume kangaroos was a dead giveaway, that this had to do more with Australia than it did with the US. But we see this come out. What I did here was I implemented a little method or a little piece of code that figures out how long it took to get the response. In this case, it took about 1.2 seconds, end time versus start time. Okay, that's great. We have a baseline. So what I'm going to do is I'm going to run another version of this 10 times. Um, but I'm going to run it with this thing that says Gemma 2B instruct FP16. So let me run it, show you the output, and then let's talk about what is uh, happening here. Okay. So we get a bunch of responses. We see 1.36 as the first one, and then we see that it really drops down to about a tenth of a second. Um, what I'm doing is I'm taking still a Gemma 2B model. I'm taking what's called the instruct variant. And so this is the one that's easier to chat with. And so I'll talk about instruct versus text separately, but just keep in mind this is what's called, this is still what's a chat model. But I'm taking a model that is, or let's say their weights that are in floating point 16. So if folks aren't familiar with how tensors work under the hood, it takes a certain amount of bytes to describe all the numbers that are in a tensor. Now you can describe that number with a lot of decimals. And I'm gonna do something really dangerous here and see if I can do a totally live demo
I
on the
thought you were
spot.
going to do something dangerous and try to import NumPy as PD or something like that.
uh, um, let's see. Can I point at random? I'm gonna say. Let's see if I remember all the API off of my head.
You do
Let's just
dot
do.
rand, I
You
think.
know, we got Gemma. Let's see if Gemma can do this for us. I'm actually really curious.
Amazing.
Prompt. Um, how do I get a random normal using NumPy? Gemma is not very well trained on code, so this is going to be an interesting one live. So you're really getting the live vibe experience here.
Mm.
Um, very verbose answer. Okay, MP random not normal. That's what I needed. Um, and actually, it worked. Okay, so here we get a number, and you can see this number has a lot of decimals on it. And if I type this number, or actually, I'm going to do something different. I'm going to do .dtype. Ooh, float object does not have dtype. Let's make this shape 2.
Yeah, I think it's actually that specifies the mean, maybe. Yeah.
Yeah, I think you're right. That does specify the mean. I think it's size. You guys are seeing some live data science coding right here. There we go. Okay, there we go. So we have what's called a float 64. So what's happening is you see a lot of numbers or more numbers behind the end. If we change the d type, and let me see if I remember this off the head, equals np dot float 16, let's say. Nope. Okay. I will show this to you later. But essentially, the more numbers you have, the more decimals you have here, just like significant figures, the more precise the calculation is. So floating point 16 means we're having a lot of numbers after the decimal. This means this LLM has what's called a maximum precision. This thing has all of its smarts. It has all the smarts to get its mathematical internals to be as precise as possible. You can actually see this if we go to Gemma 2 and we type in tags and we go to instruct 16. So let me go to let's find instruct 16 in this list. You're seeing a lot of things here. I'm going to tell you exactly what they mean in a second, but let's go find instruct 16. Instruct FP16. Here we go. You'll notice that this model is 5.2 gigabytes.
Mm.
And the same Gemma 2B model right underneath it is 1.2 gigabytes. So what's happening here is this model is bigger because it's storing a lot more information about the float tensor length than it would be than this smaller model is. So the next question you may ask is why would I use a 5.2 gigabyte model when I could save 5 times the memory by using a smaller model? So let's actually go through it and show you. So I'm going to run this same model with FP16. This time, actually, I'm going to show you the number of characters per second. And so the number of characters per second we get here is about 34, 72. We're getting some pretty fast output. This is how fast you would see the text on a screen. This is how fast you would see the text on a grad output. I'm going to run the same thing with the quantized 2 model, and we'll see that it looks like it's about the same with the shorter input, 1.4, and then we go down to a short speed. I'll explain in a second why we're seeing this, but we're going to run it with characters per second, and you'll notice the characters per second here are about twice as fast as it is for the FP16 model. And so we're getting faster output, and this is a smaller model because it's called what's called quantized. Um, it's quantized 2. And so now you're really maybe asking, why would I ever want to use a slower, bigger version of Gemma 2 when I could be using a faster version? I just realized actually that in my Gen AI guidebook, which I will shamelessly pull up, I wrote an article on quantization. So let me show you what's happening with pictures.
We actually have a great question which you may be referencing here though, or answering. Natish asks, how are quantized models trained? Is the optimizer quantization aware, or is the quantization post-processing, or?
Yes, let me answer what quantization first is for the people who may not know, and then I'll answer that second question about quantized aware training. Essentially, when you have a float 32 or float 16 model, you're using a lot of bits, which is a lot of memory, to store that the precision of that thing in memory. So this is using, as we can see here, 32 bits, which is 4 bytes. A bit is 8 bits or 1 byte. You're using this much space, this many blocks in memory to store those weights, which is why it's 5.2 gigs. When you cut it down to float 16, it cuts in half, and you can cut it down further by going to float 8 or float 4 and save a lot more memory. But the trade-off is now you have less bins or less space to store the precision of that math, and it can have a big effect. Let me show you the effect, and let me go back to the quantization aware training, because the question is, why would I bother with this much weight or this much space? You may have heard that GPUs are very expensive, and NVIDIA stock is going up through the roof. Um, when you're doing training, you can only fit so many things in memory at a time. When you're doing inference, you can only fit so many things in memory at a time. And if you can fit 4 times as things in memory as you can here from this to this, it begs the question, well, you're going to save a fourth of your server cost and a fourth of your GPU cost or your TPU cost. Why would you do that? Let's go ahead and print the actually, well, this is the downside of live demos because now it's working perfectly. But the good thing is I captured it before. Sometimes when you use a smaller quantized model, you start getting outputs that are really not as high quality. I ran this previously, which is why you're seeing this captured output. And I'm seeing that even for the same text, I'm not changing the article. For the same text, I'm getting American, I'm getting Australian, then I'm seeing a very like, let's say Gemma 1 style response where I'm getting all this extra stuff and it's flipping back and forth. And even though I'm getting faster speed, the quality has dropped off through the floor. Like great, it's twice as fast, but it's more than twice as worse. So quantization has an effect where if you start quantizing too much and you start cutting too much of the precision off, the model is not going to the AI app is not going to perform as well as it can than it would before. There is this constant trade-off of great precision and having perfect performance and quantizing a model and losing the amount of information and the amount of performance. Now, this question again is really important because you want to have a fast experience for your users. You want to save a lot of money on inference costs. You don't want to buy a TPU cluster that's 4 times the size of one that you need because they are very expensive if you tried buying a GPU or TPU recently. So there is a lot of work that goes into how can we make inference, how can we keep the quality as high as possible while making inference as cheap as possible. Quantization is one of those techniques. The question we got is about quantization aware training. Something that folks noticed is that if you just take a model and you train it in full precision, and then you just quantize it afterwards, you tend to get quality losses. They're not often huge, but you get them. One way to mitigate that is that you can do what's called quantization aware training, where you can quantize the model and then keep training it some more, and it then tends to recover some of its forgetfulness and reach a very similar performance score to the unquantized model. But you get that now with a quantized model. So you kind of get the best of both worlds. You get a great model that doesn't lose too much performance, but it happens to be smaller, so it's cheaper and easier to serve. Now, the other thing which we saw, which I didn't talk about, but I promised you I would get back to, is this drop off right here. The first query takes 1.3 seconds, but subsequent queries take a lot cheaper. The reason this is happening is there are a list of inference optimization techniques that people are using these days. One of these top optimization techniques is something called a KV cache, a key value cache. For those familiar with the internals of transformers, queries, keys, and values are at the very heart of how transformers work. And it turns out that when you run the same prompt over and over again, you actually don't have to redo all the computation over and over again. In an inference setting, well, in a training setting, you're giving the model all sorts of different things, so it can't really, it doesn't really get the same prompt over and over again. But in an inference setting, often users, once they find a use case, do the same thing over and over again. They don't really, they may stick in one lane and like we're doing here, not ask much more than, hey, is this an Australian or an American team? Even though a model can do many, many more things. So KV cache kind of pre-stores a lot of the computation that it takes to process this string. And you're seeing that here with the 1.3. Uh, and then because it's already done this part of the computation and it really just needs to do the last bit over again, it dramatically speeds up and gives you much, much faster answers with way less computation needed. So quantization is one inference time technique. KV caches are another inference time technique. There are many others. There's ones called speculative decoding, which you can read about in Google. You actually take two models, a big model and a small model, and you have them work together to get things out really fast. Having really good inference time speedups is a key area of research, just as much as capability research and and model architecture research and all the other things. As these things get used more and more and more, there's a lot that can be done just to make them easier to use after training. This this comes to one other question we had about thinking models. Very recently, thinking models have pushed more and more capabilities into the inference time of the model. Inference meaning when you are not updating the weights anymore, but just having the weights compute that generative answer. By having these thinking models like a DeepSeek, an O1, or other models, a lot of the compute happens at inference, so there's even more pressure now to make inference time compute very, very efficient, so we can use these thinking models without having to pay a ton of money and compute cost. So I haven't been paying attention to the chat because I have my screen shared. I'll go ahead and take a look right now, but Hugo, if I missed anything, you can call it out as I read. I see nothing in Discord and maybe nothing on YouTube. So let me
Sorry,
let
I
me
was muted, and yeah, no, there was nothing. So yep, we're good.
okay. Awesome. So let me do the recap then for inference times technique, and then that'll be the very end of our scheduled part of the tutorial. Inference again is as important as training. Inference time techniques are showing users always are doing something in inference. They come with their own question. There's not like a pre-canned list of questions that have already been pre-calculated for MLMs. So you get what's called inference at that point. But as we get to thinking models, it becomes more and more important. There are many techniques. I listed a bunch in that same guidebook that I showed earlier. Um, that are or this article goes much more in depth about inference time techniques and different references and papers that talk about specifically just about all the work that goes in just on inference time compute. So we're not going to go through this paper right now. This isn't a paper club, but I just want to point out that in your AI app development lifecycle, as you do your vibe, as you pick a model, as you do your vibes check, as you build your eval harness, and you get to inference, uh, all these things work together to make a really smooth experience for you and for your users. So that's all I have for the pre-planned portion. Hugo, you have anything you want to add?
No, I think, well, maybe actually just going back to the slides if you have them open, just a general recap of what we've done. I may have them as
Oh,
well.
if you have them, yeah, grab them.
I do. Yep. Um, and that's cool. I mean, we're happy to chat and happy to answer questions. Actually, I'm sorry, I do have a question and a statement. The question for you, Ravin, is I think you were able to try these different models. Sorry, let's just step back a bit. we're trying different models for a number of reasons. First, because it's fun and we want to see what's up. We want to see what all these new models are. At least I do. I love playing with them. Actually, there's a tool called LM Studio, which is super fun to play around with. And the when you open the product, it kind of looks, it shows you all the new models and you can select them and do it, but you can actually load different models and see how they compare to each other and that type of stuff as well. So that was the inspiration behind the Gradio app I suggested, among other things. But the other reason is you do want to see if you can improve your models, if you can reduce cost. And what do we care about, right? Generally we care about how expensive is it, how long does it take, and how secure is it, right? They're three really, and how fast is it? Okay, so we've got cost, latency, and security or privacy. Now, as it turns out, using local models and open weight models that you can host yourself, far better in terms of privacy, and in the end can have far better latency and cost as well. So in those respects, Ravin, the instruct model you tried and the quantized and this type of stuff, you were able to try them because you're an insider, because you and an expert, you know stuff about this. So for people kind of starting on this journey, or even people who haven't necessarily played around with a lot of different open weight models, what rules of thumb or heuristics would you give people to think about what type of models to try? Should they try the instruct quantize one first, or should they try something else? Or how do you think about this?
There's a couple ways I think about this. One is if you have if you know what your use case is in mind, like you know you want to use, like if you know you're gonna definitely want to use images, you know you definitely want a model that has what's called so much context length. If you know there's certain constraints to what you need to do, then you can use those to find the models that have that match that criteria. For instance, if you know you want to use images, Gemma 1 and Gemma 2 don't support image input right now, so you wouldn't want to use those. You'd want to find some of the others like Polygemma or the others that are out there. That's one easy way to segment it. I think another way to do this, and I'll give a shout out to the Olama people again as well. They've already done a lot of this thinking for you. So you just type in Olama run and the model you want to run, and they pull by default they pull down the best default of that model family for you. So if you type in Olama run Gemma 2, you're gonna see that you just get a model, and they're gonna I forgot which one they recommend, but essentially you're gonna get the recommendation as a default, and it's a good starting point. And then when you're ready to dive deeper, then you can go look at those 94 other models that they have in there, and you can pick your model size, you can pick your quantization, but you don't have to worry yourself about that decision at the beginning. You can just use Olama to grab one and just do some basic vibes to see if you're in the ballpark. So that's kind of how I've been running things. Even because these models keep coming out every week. Like I can't, even though I'm technically in the inside, I'm not really in the inside because I'm not at every company deploying LLMs and releasing them every week. Just like you, I hear about the latest model, a lot of models on the news, and from Blue Sky and other places. And so, especially if they're open models, I just, yeah, again, just Olama run, pull the version of them, and just vibe check it and see how it seems to stack up. Once I think I'm going to seriously use in production, then I do the whole eval thing that we just talked about. But this is how this is how I keep up the current climate.
I appreciate that. And what I'm going to link to the subreddit Local Llama, which is a wonderful, and it isn't actually, it looks like it's about local llama models. It's about all of these things more generally, local models, other types of models, generally about people, using LLMs and chatting about them. I really do encourage everyone to follow Simon Willison on Twitter and LinkedIn, Jeremy Howard, Shreya Shankar, Chip Huen. I'll put all of these names in the chat. Maybe I should actually just put together a doc of the people I follow and learn from. Sebastian Rajkar is absolutely fantastic. So yeah, I'll put together a few ideas of ways to think about this. So having said that, once you've played around with another model and you think it's better with respect to your business needs and cost and whatever it is, what I want you to do now is we're not going to do this now. You can go and switch it out in the Gradio app. And I left a comment for Helena had a great question. How do I share the Gradio app? When you do iface.launch, you do share equals true, and that will give you a URL that you can share with friends. So what I want you to do is create a little app with your model of choice after going through this evaluation process. and share it with a friend or share it with us on Discord as well. Now, of course, it will be running locally for you, so you need to have your laptop open. Maybe we can do another workshop about getting these local models up and run on infrastructure so you can close your laptop when you go to dinner. And that's a good thing. What we'll do is actually on Discord, we'll ask you all what type of things you'd like to learn next as well, and see what we can organize and put together. But definitely iterate on the Gradio app that we built earlier on. What I do want to do now essentially is just have a general recap of what we've done more generally, right? So we've built an MVP system with models, data, front end database, zero shot learning, text classification challenge with footy teams and then news articles to classify as American or Australian using Gemma 2B, and we saw it with a bunch of other models. So similarly, it was really this type of thing. And forgive me, this is a slide from the course, but where we have a front end, we didn't use Llama Index here, which is actually good. Funnily, in the course, we use Llama Index, and then what we get you to do next is to rip Llama Index out and to do it with pure Python, because you can't even, I mean, Hamel has this post, which I'm quoting verbatim. Actually, I'm not going to share it, but it's called "Fuck you, show me the prompt," and I'm quoting him there. I just want to be very clear, but it's a cuss word used for communication purposes. And the issue with a lot of frameworks are you can't even see the prompt that's being sent. So we get you to rip it out, use a pure LLM. But essentially, what we did here is then we logged with SQLite, looked at it with dataset and Excel and the CSV, right? Then we started doing our vibes checking. So we tried a prompt locally using Olama from the command line with Olama run model name, got a vibe, tried other prompts, and tried different prompts at teams. Then we introduced repeatable evals using an eval harness, which is a repeatable eval script designed to systematically test and evaluate performance. We did this programmatically for a bunch of teams, and then got you to try with news articles. And we did that in a notebook. Then we did it in a script as well. And this is something you can automate as also. And then we thought about inference and optimization and tried different models to measure speed, accuracy, and cost, and thought about how you would monitor these in production and running experiments to improve one and check for the impact and effect on others. So I'm happy to chat a bit and answer questions. I'm also happy to end a bit early so we can get on with it and work on the next tutorials that we'll build. I do want to say you've all been welcome to the Build with LLMs Discord, and Ravin and I are figuring out what channels that you can have access to and those types of things. But we have a resources channel and a technical questions channel that I'll add you all to. And feel free to introduce yourself in the introductions channel. I'll add this in Discord because we've got nearly 100 people there from the first cohort of the course that Stefan and I taught. And we'd love, like, if you're in the same city as some of them, feel free to interact with them, and maybe you'll see colleagues and friends there as well. I am once again cheekily going to share this link to the course that we teach, and we've got our next cohort starting in April. If you're interested, and feel free to reach out with any questions. And as I said, Ravin gave a wonderful guest lecture last time there that this workshop is a child of in many ways. But what I want to make sure is that you'll all feel capable and encouraged to build and then chat with us and let us know what you do build in Discord, and do ask any questions there as well. Ravin, is there any, I see Nitish has said looking forward to your Gen A guidebook live streams. I didn't know you were doing live streams with the guidebook.
Oh yeah, I was for a period of time, and I need to kick them back up. This is a good reminder how fun these live
Amazing.
streams.
Maybe we should do one together sometime from
I
your
would
guide.
love that.
That would be super fun. So if there are any other questions, we're very happy to answer them. But Panda has a great question, which I'm not sure how does one protect the model from naughty bears that may corrupt the model? Can you interpret what a naughty bear is from Panda, Ravin?
I don't. The only thing I can think of maybe with his username is maybe how do I protect a model from himself or themselves? But I don't have a good answer to that.
Yeah. Um, cool. Well, look, actually, since we have a bit more time, Mr. Me, 77 says, what tokenizer would you recommend looking up? Ravin, we didn't really talk much about tokenizers, and because that was outside the scope, but we do have a bit more time, so maybe you could tell us a bit about tokenizers.
Yeah, okay, that's a good question. So, tokenizers are the thing that that pre-processes a text or an image and audio before it goes into an LLM. They're it's I guess that people debate whether they're part of the model or not, but we could definitely say they're part of the current LLM ecosystem. So, if we start from a research perspective, there's a lot of debate on what whether tokenizers are needed or not, or whether they play a critical part. In the future world of LLMs, we may see what's called tokenizer-free LLMs. There's some research being done on that. But for the current time, you have these things called tokenizers, which chunk up text or images or audio or whatever else, and then you have an LLM that operates on what these called tokens. The two the tokenizers. So Mr. Me says byte pair encoding tokenizer. Um, that is BPE stands for byte pair encoding. That's a method of tokenizing text. But the two implementations at a more concrete level that you'll see quite frequently are sentence piece from Google and what's called tick token from OpenAI. Though other companies are also making their own. But it is important to note that you can't just take a tokenizer that from one company and just bolt it onto a different model. Once a model is trained with a particular tokenizer, it has to use that tokenizer. There's a little bit of wiggle room in a research setting. And when I talked about the Michelin star level stuff that you saw me earlier talk about, uh, the experts sometimes will do some tricks at the tokenization level. But by and large, 99% of people I'd say building AI apps, you're never gonna need to worry about the tokenizer. You just pick whatever model or whatever you want, or actually, you'll probably never even think about the tokenizer. You'll just pick one of the models and it'll come with that tokenizer and you'll just use that tokenizer. If you are curious about tokenization, um, I think I always forget. I've written about a bit about that in my guidebook. If you want more from me, just ping me in one of the channels and I'll provide you more information on tokenization itself.
So
But
yeah,
if you want,
there is some great stuff about it in your guidebook. I've also linked to Andre Karpathy's incredible video called "Let's Build the GPT Tokenizer," which is like a 3 hour stream of him showing you how to do that. And I just think also like all the AI stuff around is great, but what an amazing world we live in that someone like Andre Karpathy will just drop videos that we find as useful as we do. Isn't that awesome, Ravin?
it is very great, and just someone of that caliber takes the time out to share his knowledge with the world.
Yeah. And I think this is obvious to everyone, but just to be clear, LLMs are not next word prediction machines. They're next token prediction machines, right? So it like everything is actually happening at a token level
Yes.
as well. Um, super cool. Well, I think probably it'll be time to wrap up and we continue the conversation on Discord and or GitHub if you want to raise issues there as well. So Ravin, any final words, or I wonder actually, perhaps we could. You already showed us a bit of AI Studio, but do you want to just give us a quick tour of AI Studio again and show us a few of the things in it?
Yeah, while we're here, can't hurt. Um,
One thing that we didn't, I hinted at, someone mentioned in the chat, is that you can play around with it and it gives you the code essentially, so you can play around with it and build simultaneously.
yes, and I can show you some of those features because we talked a lot about Gemma, but I didn't talk a lot about Gemini, which is the large class of hosted models that Google has. Um, So to provide context again, I talked a lot about Gemma, which is Google's open weight text in, text out models, although there are different variants of Gemma that have more in them. But the other model you've more likely heard of from Google is called Gemini. It's the frontier series of models. And these models are not open weight. You can't just download them because they are big and complicated, and there's a lot of things going on. But they are available through aistudio.google.com. So here's the link here, and I'll let Hugo type it in. But what AI Studio is, and maybe the easy way to think about it, is it's Google's vibe check front end for the Gemini classic series of models. So let's say you're a developer and you want to use the Gemini models in your uh, classification app or whatever app you want, and you need to do a series of vibe checks. You would just go to AI Studio and you would just start typing. You would just start typing things in. Like I say, tell me. I'll make this bigger. Tell me if this is an Australian or American team. And without even doing this, by the way, I'll let you know that Gemini is going to nail this. It is, and I have to go here and put in Gemini. Um, the Gemini series of models are just going to nail this. They are incredibly capable on a wide variety of tasks, and they're very instructable, and they have various levels of instructability, like system instructions or what's called developer instructions. So they've got a ton of features I won't go into now. Um, but Google puts a lot of time and effort in making these super capable models. And so you can go here, you can try them out. If you want to use them in your own app, you go over here to get code. I think I'm messing up the UI a little bit. Oh, you can go over to get code, and you can just copy the
So
code
cool.
straight into a Colab or a Python script or whatever you want. You can get an API key right over here, and I'm covering all this UI up, but you can get an API key here with one click. I'm gonna have to go burn this API key now that I showed it on a live stream. Um, but
Story
you
of my
grab an
life.
yeah, you can grab an API key, but it's a really great place to try out Gemini's models. And so some quick pitches. It's fully multimodal. It can take in audio, it can take in video. You can see some of the knowledge here. It comes in different sizes. So Flash Pro
Yeah.
is the big size
Can you
model.
just talk us through what Flash and experimental and thinking, like all these different things are?
Yes. So Gemini, just a lot of these LLMs come in different sizes, or different. You have very, very big models, like a Pro, and these are the most capable ones, but they tend to be, let's say, the most expensive to use because they're just so big and they have the most amount of power. Then you have still capable but smaller size models like Flash. And so with I'll call them medium-sized models in this context. These medium-sized models can run very fast, but they may not have the same capabilities or knowledge that the very, very large models may have. Um, and then you get to the really, really small sizes like a Gemma models, which are 27B or 2B. And so I will say every LLM provider has different namings for these things. You know, there's Claude Sonnet and Haiku, and there's others. With GPT, you have 4.5, 4.001, and I think you may still have 3.5. I like forget at this point whether it's still available or not. But they all run with these different sizes. The question becomes, which one do you use? If I just can make a pitch for the tutorial that we just did for 2 hours, the best way to figure out which one you should use is do vibe checks. Start with a big one, see if it works. If it does, then find the smallest model that still passes your vibe checks, or at least looks good on your vibe checks. Then create that repeatable harness and test a couple out, and then you can nail down which is the right one to use. So the way I do things, I'll start with Pro. I'll do some vibe checks, see if my thing is even possible with the current state of LLMs. If it is possible on Pro, then I know it's a solved problem. If it's not possible in Pro, then I know it's probably a little bit outside of the reach of LLMs right now, but I keep it in mind to check in a couple months. Once it works on Pro, I'll then try Flash, see if I can get some faster inference and cheaper cost with my use case. If that works, then I'll try the smallest version, which is Flash Lite. Um, but I'll keep going to the cheapest model that works until I can build my app and I'm good with it. So
Can I also just give you a chef's kiss for the UX here? The fact that when you hover over a model, that panel, would you mind hovering over a model
oh,
and
yeah.
the panel that comes out that says best for use case, latency, all of these things is so nice. I think I'm going to complain about ChatGPT because I currently pay $200 a month. And this isn't just me, this is a very common complaint, but the list of potential models you get in ChatGPT, and I can't even remember what is used for what. And it really doesn't, is totally unhelpful in the UX. So thank you for caring about product. I do think generally people care less about product than they do about models at the moment. So seeing seeing good product shipped is actually really heartening, Ravin.
I think to your point, we just want to give people a vibe check without even getting without even having to load a model. So you see the latency in the bottom right. That was Notebook 4. You don't even have to run the vibe check yourself to get a sense. The little blue bar there will tell you whether it's faster or slower. But this is to say, let's say you want to try using LLMs, even if you want to try using Gemma 2B, 9B, or 27B, the Gemma 2 models. You can vibe check all of them without having to install anything on your computer. You can vibe check them on your phone for all that matters at this point. Um, this is the point of AI Studio, as the name implies. It's supposed to be an AI vibe place to see what works for you.
Um, we have a great question in the chat from Igor. Again, this Gemma model, does it support structured outputs?
So this is a very interesting thing because actually I can show you in here, since we're here, we can talk about structured outputs in AI Studio. So here you can see that I clicked the structured output checkbox, and now I can force a structure and say, what is this team Australian? Let's say American Australian. I'm just gonna keep using this because you are all now familiar with this. Australian. We'll say Melbourne Kangaroos. And let's pay attention to the output. So I'm going to go ahead and hit run here. And you can see that I get a very structured output of JSON. This is amazing for developers, right? You don't have to worry about text formatting or any of this stuff. This will just import JSON-S or JSON load S in Python, and you've got your team name. It's absolutely beautiful. If I turn structured output off and I delete this and I run this again, I messed. Oh, I messed up the UI a little bit. So let me reload a little bit with too much going on with Zoom. Okay, you see that I get a longer output. I didn't put any instructions here to make it short or long. It just does whatever it wants. So again, I just flip the structured output, and I'm going to run it one more time just to show you the magic. And this time I guess maybe my share screen is messing. This time we get a structured output that looks a little bit different than the last one. What is happening here and what the structured output is doing is in an LLM system. So with the question of tokenizers, LLMs, I think, are these AI models are not just a model of math. They're a system of tokenizers and samplers and all sorts of little things that make that Michelin starred meal that we talked about at the very beginning, right? Like a Michelin starred meal isn't just one ingredient. It's a lot of different things coming together to create a very unique or bespoke thing for you. And that's really what these LLM apps or deployed apps are. So what's happening here is that there's a structured, there's some additional tooling that allows for structured outputs. In this case, specified a JSON output, but you can specify anything you want. So it takes an LLM and it does some very, very clever tricks at the sampling level to make sure that the outputted tokens match a very specific structure. Now you get that for free on an API because Google has already put that code into the AI Studio app for you and in the API. So you just pass one flag, true or false for structured output. Or actually, I think it's a little bit more than that. But you basically pass some config and it gets it. For local LLM, you're gonna have to do that yourself. So in your in that notebook, or let's say in the requirements file that we provided you for the tutorial, you're gonna have to install a library like Outlines, which comes from a colleague, Remy, another Bayesian. For those that don't know, Hugo and I, and there's a core group of us that are very Bayesian. Remy is one of these folks.
Probably very Bayesian.
Very Bayesian. The three of us and others are very, very Bayesian. He also has he built a library with a team called Outlines, which does structured decoding. So you can let me just pull up his docs. Outlines, and then I'll talk an LM.
I'll put in the
He's
chat
got
as well.
Oh, okay, awesome. He's got this library where you can similarly pass in a schema for an LLM and have a local model have some structured output. And so if you're building using things with your own local models, you'll need to put the tooling together. But if you're using, let's say, the Gemini API, you get that tooling quote unquote for free.
Super cool. And I'll just note that you've got function calling, you've got grounding with Google search. I mean, structured output is just the beginning.
Yeah, we put a lot of features into the Gemini API. There is hopefully everything that a developer would need, an API developer would need to to create their application. So part of the reason of this is for developers like yourself. Let's say you try running using the Gemma models and you're just finding they just don't give you what you need, and you need to get to these closer to frontier, smarter models. Um, our goal with AI Studio is you can do your vibe check and then get your code and then get your grad AI up running within like a weekend. You don't need to fiddle around too much with figuring out all the code and everything. It should all just be pretty, hopefully just pretty copy and paste from Vibe evals for you. Just like this one. This was with this Vibe eval, you can see that this is literally the prompt that I just put in. Um, we have the structured output right here. And in here, the response should be a JSON type. And so it gets that all these pieces from the settings in the UI.
Super cool. And I just remembered, I just linked to the podcast we did last year, Ravin. I had Ravin on my podcast, and we did an episode called "From Models to Products: Bridging Research and Practice in Generative AI" at Google Labs, and that was before you moved to DeepMind. But for anyone who wants to hear more from Ravin, definitely check it out, because it was such a wonderful conversation. And I'm excited for the next one. Let's wrap up and continue the conversation on Discord. But any parting words, Pravin?
No, just Hugo, I appreciate you always pulling a great bunch of folks together and collaborating with you. So thank you for you personally, and for all the folks that came through all the various time zones and days. Spain is the day ahead. I think a lot of folks from the US showed up with me and are here till 9:30. Appreciate you taking the time out of your day or evening or wherever you are to sit with Hugo and I.
Absolutely. Yeah. Thank you so much. And thank you for the great engagement, the great questions. It went in directions that were unexpected for me. And I really love that. And I don't know if anyone, thank you all for not watching the Oscars. Not that that's something we'll necessarily do, but thanks for being here and playing around with building generative AI apps with us. Do when we're doing more of these types of things, we'll let you know on Discord. Please do connect with both of us on LinkedIn. It's our names and essentially to find out more about this type of stuff. And excited to continue the conversation on Discord. So thanks everyone, and thanks most of all, Ravin, for the collaboration and the great workshop.
Appreciate it. All right. I'll see you around, Hugo.
And scene. So I've stopped the live stream.